Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Welcome everyone. Thank you for taking this course by Coding Bootcamps. This course is all about Hyperledger Fabric for system admins. In this course, you will learn how to manage Hyperledger Fabric networks. A little bit about myself. My name is Sushma and I will be the instructor for you in this course. I have a master degree in computer science and information security, and I also have a master degree certification on blockchain. I have 6+ years of experience and I have worked as a Java developer, web developer, full stack engineer, and also a tech lead in my career lane. My main interests at the moment are blockchain, IoT, DevOps, and cloud infrastructuring. In order to take this course, you need to have basic understanding of Linux command, basic understanding of how blockchain technology works, and basic understanding of Node.js programming language. As part of this course, you will be going through the following list of topics. We will see the overview of blockchain technology. We will see the anatomy of blockchain technology. Then we will get into Hyperledger blockchain ecosystem. Next, we will go deep into Hyperledger Fabric components and architecture. Next, we will go and look into Hyperledger application lifecycle management. Then we will install and configure Hyperledger network. We will also run some troubleshooting on Hyperledger network. We will see how membership service provider works with Hyperledger Fabric, and we will also see network maintenance and operations on Hyperledger Fabric network. We also have the projects or the lab sections where we will have hands-on experience on creating and interacting with the Hyperledger Fabric network, and we are going to create the Hyperledger Fabric network from the ground up. So that is for the lab 1, which is project 1, and in the project 2, for the existing Fabric network, we are going to add one more organization to the Fabric channel. So you already have a Fabric network and a channel created in project 1. In order to continue, in order to add one more organization, what are the steps that you need to take? That is what we will be covering in project 2 or lab 2. After this course, you will be comfortable in knowing what blockchain technology is and the components and architecture of Hyperledger Fabric, and how you're going to form the Hyperledger Fabric network, and you will also have hands-on experience on of creating Hyperledger Fabric network on your own. So you can also find many other courses that are present in coding boot camps. The links are provided here. Please do go through all these links if it interests you. Thank you for taking this course by coding boot camps, and I'll see you in the class. Thank you. Welcome everyone. Thank you for taking this course Introduction to Hyperledger Fabric Management for System Administrator. This course is brought to you by Coding Bootcamps. In this session, we are going to learn what blockchain technology is and the basics of blockchain. A little bit about myself. My name is Sushma and I have 6+ years of experience. I have played a role of Java developer, web developer, full stack engineer, and a tech lead in my career lane. I have a master degree in computer science and information security, and I also have a master degree certification on blockchain. To take this course, you should have basic knowledge of Linux command, basic knowledge of blockchain technology and how it works, and basic knowledge of Node.js to write smart contracts and the application. This is what you are going to cover in this session, which is introduction to blockchain, what blockchain is, and what are the types of network, what are the components of the network, what are the use cases and examples of blockchain. Before going into what blockchain is, let us understand what do you mean by centralized and decentralized model. So as you can see in the centralized model, which is on the left side of this picture, so one person or one organization is responsible for storing data. If you want to be a part of that system, you should trust the system with the data that you are providing to the system. So this organization is the source of truth for the data. And as you can see in the right side, which is decentralized model, there is no single source of authority which is holding your data. Every participant in the network can communicate to every other participants in the network, and then it doesn't have to depend on one single organization for their data. So each of the peers can store their own data and they can communicate in the network freely. So here, as you can see, the data is more decentralized when compared to the left hand side where the data is centralized. In the decentralized model, we are not investing our trust on one organization. Instead, we are investing our trust on the network. So with decentralized model in mind, we can come to a conclusion that that is the first step towards blockchain. So this is where blockchain comes into picture. With blockchain, we move away from trusting only one single authority. Instead, we trust the system. So as we all know, Bitcoin was the first blockchain which got the popularity. So Bitcoin was originally devised for digital currency exchange. So Bitcoin is not blockchain. The underlying technology that Bitcoin uses is blockchain. So after the popularity of Bitcoin, many innovative ideas have come forward which can take advantage of this underlying structure which is blockchain. So who coined this term? A person by name Satoshi Nakamoto. So it's actually a pseudonym. So we don't know whether Satoshi Nakamoto is a person or an organization. So he is the one who thought that he can use the existing systems like digital signature, peer-to-peer networking, and hashing algorithms, and many other existing technologies, and he can build the system which is gonna originally used for Bitcoin blockchain system. So Bitcoin, as we already know, was originally devised for digital currency exchange. So after that, we came to a conclusion that blockchain can be used for other use cases as well. So now let us see the hyperledger.org definition of what blockchain is. As you can see from the slide, a blockchain is a peer-to-peer distributed ledger forged by consensus combined with the system for smart contracts and other assistive technologies. So what do you mean by that? What do you mean by peer-to-peer distributed ledger? That means it doesn't have to deal with a single server. All transactions are distributed in peer to peer. So there is no single server or the single entity that the network has to trust. And what do you mean by consensus? So what transactional data that has to be stored on the distributed ledger is decided by a process, and that process is called consensus. Now, what do you mean by smart contracts? So, smart contracts are the programs that we place it on the network, and when certain conditions are met, smart contracts will get executed on its own. So, we will learn more about smart contracts moving forward in this session. Next, we are also stating other assistive technology. So, what are other assistive technology? They are digital signature, hashing algorithm, peer-to-peer networking, etc. Now, why the name blockchain? The term block refers to a set of transactions that are bundled together and added to the chain, and every peer has this block added at the same time. That is why it is called block. It has block in it. Next, the block will be appended to the existing block and the process continues and it forms a chain. So that is why it is called blockchain. So there are different types of blockchain network, as you can see from the diagram that we have made here. It is mainly classified into public blockchain, private blockchain, or permissioned or consortium blockchain. So each of these categories has their own implementation. For example, you have in permissionless or public blockchain, you have Bitcoin as an example, and so on and so forth. So the main focus of this session is Hyperledger Fabric. So we will get deep dive into what Hyperledger Fabric in this session. So you can also have a look about all the other types of networks as well. So please go through this slide to understand the difference between the public network, private network, and permissioned or consortium network. So this slide tells you what are the difference between public and private and consortium network in terms of their network type and who can be part of these networks and what are the benefits of these network and what are the challenges that these types of networks are currently facing. Please go through this slide. Now, you may think that all use cases in industry are fit for blockchain, but that is not true. So, in this slide, you can arrive at an answer whether your use case needs blockchain or not. Let us understand this. So, if your application needs a database, so you have to ask yourself a question: does your application need a database? If the answer is no, then you don't need a blockchain. If the answer is yes, and you should ask another question: are there multiple writers? If there is single writer, then you don't need blockchain. And if you have multiple writers and all if the writers can trust somebody, then you don't need blockchain again. If the writers cannot be trusted and so there is no trust between the writers or the data changers of the application, then you have to go for blockchain. If they can trust somebody, then you don't need to go for the blockchain. So this is the slide where you can decide whether your application you can leverage blockchain or not. So there are different components of blockchain. So there are many components. So the main components of the blockchain are listed here. First is consensus, provenance, immutability, finality. So consensus refers to system of ensuring that parties agrees to a certain state of system as true state. Provenance system tracks changes that are made to data, where data originates and moves to, and who makes change over it. Immutability: an immutable object is an object whose state cannot be modified after it is created. Finality is an affirmation that all well-formed blocks will not be revoked once committed to the blockchain. Now, there are many use cases of blockchain. A couple of them are listed here, which are decentralized cryptocurrency, just like Bitcoin, asset management, payment, blockchain IoT, smart appliances, supply chain sensors, and many more. Please go through this link where we are listing 50 plus real world blockchain use cases and the companies which are currently harnessing and using blockchain technology. So that is it for this lecture. In the next lecture, we are going to look into anatomy of blockchain. So please subscribe our private tutoring coaching session if you want to get much more details or in-depth details and personalized tutoring for all this course. Thank you for watching. I'll see you in the next section. Welcome back everyone.
Thanks for watching. Feel free to add your questions as comments down below.
In this section, we are going to look into anatomy of blockchain. In the previous section, we have learned what blockchain is, what are the types of network, what are the components, use cases, and couple of examples of blockchain. In this session, we are going to look into blockchain structure, blockchain lifecycle, smart contract, different types of consensus algorithm, who are the players in the blockchain, and couple of other details which are related to players in the blockchain. Now let us understand how blockchain works. So blockchain technology is a peer-to-peer distributed ledger that can record all transactions of two peers or two parties securely and efficiently. These transactions are stored inside blocks. Blocks are linked to form a chain. The creation of block is done through a process of consensus in peer-to-peer network where peers work simultaneously to solve a complex mathematical problem to validate the block. Once the block is added to blockchain, you cannot change it. Even if you try to change it, it is easy to verify that it is not a valid data. This is the main reason why blockchain is secure. In this slide, you can see how blocks are stored in the blockchain. As you can see, these are considered as block, which is uniquely numbered. As you can see, block 10, block 11, block 12, and the chain continues. So as you can see, every block contains different fields. As you can see, previous hash, timestamp, transaction root, nonce. So these are the different fields that are present in block. One interesting field is the transaction root, which is also called Merkle hash root. Now let us see what Merkle root is. Before that, let us understand what Merkle tree is, or Merkle data tree, or Merkle hash tree, whatever we call. So let us see what is that. So Merkle tree is a data structure and it's nothing but a binary hash tree. Merkle tree stores the hashes of individual data or individual transaction in a tree structure, which makes the verification of dataset or transaction efficient. Merkle tree summarizes all the transaction in a block, producing an overall digital fingerprint of an entire set of transactions. Because of Merkle tree, you can easily verify whether a transaction is part of the blockchain or not. So when you have, let's go to the previous slide. So as you can see here, the transaction root, this transaction root contains all the transactional hash of main. So as you can see, let me explain it clearly. So you have four transactions and each of the transaction is hashed to a particular hashing value, and they are combined, and the combined value hashed value will be present in the transaction root. So with this, you can easily verify whether a particular transaction, for example, transaction 1 is part of this block or not. So that is the advantage of Merkle hash tree. The lifecycle transaction differs from one blockchain to another blockchain. For example, lifecycle of a transaction on Hyperledger Fabric is different than lifecycle of a transaction in Bitcoin. Now let us see what is the lifecycle of transaction on Hyperledger Fabric. So in the left side picture, as you can see, there's something called MSP. So we're going to learn what MSP shortly. So MSP is nothing but the membership service provider that enrolls the user and application to the blockchain network. After the enrollment, the application submits the transaction proposal to endorsing peers. Endorsing peers simulates the transaction and responds back to the application. Application then submits the transaction to the orderer. Orderer sorts the transaction, assembles the block, and sends to the committing peer. So committing peer validates the transaction and updates the ledger. So this is the simple way of explaining how transaction works in Hyperledger Fabric. As we move forward in this course, you will understand the detailed process. As I've told before, the lifecycle of a transaction differs from one blockchain to another. Let us see the Bitcoin transaction lifecycle. So the lifecycle of a transaction on Bitcoin is is basically transferring the currency from one account to another. So, as you already know, Bitcoin is a currency transfer platform. A peer initiates the transaction, and once he initiates the transaction, he enters the destination Bitcoin address, and he also enters the amount that he wants to transfer to the destination Bitcoin address. After that, he authorizes the payment using the private key, his own private key. Then this transaction will get validated by miners, and miners are nothing but the peers in the network. So miners who solve the proof of work problem propagates propagates the new block to the network, and other miners verify the new block, and the payment will be sent to the destination address. So this is in short how the transaction works in Bitcoin blockchain. Now let us understand what is smart contracts. So smart contract is a computer code running on blockchain network. It contains a set of rules under which both parties have agreed upon. When these rules are met, the agreement or the smart contract will get automatically executed. So smart contract between two parties is mainly for transferring digital assets in the network. Now, since we understood the definition of smart contract, now let us understand how smart contract works. So this is a pictorial representation of how smart contract works. So in the first step, the smart contract is written as code into the blockchain network. In step 2, when certain event occurs, the smart contract code will get automatically executed. In step 3, which will lead to transfer of assets from one party to another party in the network. In step 4, since this transaction is stored in the immutable data structure which is blockchain, any regulator can verify the transaction. So this is in a nutshell how smart contract works. Now let us see what a consensus algorithm. So in order for the network to decide which transaction should form a block and where it should be placed in blockchain, the consensus algorithm should be in place. Consensus algorithms are designed to achieve reliability in a network involving multiple rules. So there are different types of consensus algorithm. Couple of them are listed here, which are proof of work, proof of stake, practical Byzantine fault tolerance. So proof of work. So proof of work is a system that is used to process blocks of transaction and add them to the blockchain. So here a term, what do you mean by mining? So there is a term called mining. So what do you mean by mining is? So mining is a process of generating correct proofs in order to add a block to the blockchain. And individuals that participates in the mining process are called miners. So proof of work was first used by Bitcoin blockchain system. So proof of work requires miners to solve complex cryptographic puzzles before they can add a block to the blockchain. In exchange for solving this puzzle, the miners get rewarded with Bitcoin. So this is what proof of work is. And when it comes to proof of stake is a system where miners or peers that are chosen to generate the block, and these miners are called validators. So you may ask yourself, who can be a validator? How these validators are chosen in the system? In proof of stake system, validators are chosen to generate a new block based on their economic stake in the network. So if you have higher stake, you have a higher chance of becoming a validator. So what is Byzantine fault tolerance? So before getting to know what Byzantine fault tolerance, please familiarize yourself with what Byzantine problem is. So in order to tackle Byzantine problem, we came across with Byzantine fault tolerance. So fault tolerance is the ability of distributed computer network to function as desired and correctly to reach a sufficient consensus despite of malicious nodes in the system who tries to propagate incorrect information to other peers in the network. The main objective is to defend against any catastrophic system failure by mitigating the influence of malicious nodes who are propagating incorrect information. As a result, we can reach the right consensus by honest nodes sending the right information. So this is what Byzantine fault tolerance is. Now, who are the players in blockchain? So there are different players in blockchain and couple of them are listed here. So blockchain architect will be responsible for architecting and designing the blockchain solution. Blockchain developer is responsible for writing the application smart contract that interacts with the blockchain and are used by the blockchain users. So blockchain user is a business user operating in the business network. This role interacts with the blockchain using an application which is written by blockchain developer, and they are not aware of the blockchain, meaning they are just end users. Blockchain regulator, the overall authority in a business network, specifically regulated. Regulators may require broad access to ledger content. Then you have blockchain operator. So they manage, monitor the blockchain network. Each business in the network has a blockchain network operator. You have membership services where it manages different types of certificates required to run a permissioned blockchain. You also have different systems like traditional processing platform and traditional data source where you need to interact blockchain network with the other third party platform or data source as well. So you might have heard of distributed application, which is also called as dApps. So dApps are nothing but your front end code and also your contracts written on the network. So if you can see, distributed application code can have their own front end, distributed front end as well, and you have different applications or different decentralized storage such as Swarm and IPVFS, where you can host this distributed storage or decentralized storage. So you can also make different components of the dApp distributed as well. For example, you can make front end distributed and you already have the smart contracts distributed as well. So your distributed application is nothing but the front end and also the smart contracts. That is it for this lecture. In the next lecture, we'll get into what Hyperledger is, the family introduction of Hyperledger, the design philosophy behind Hyperledger, the architecture on which Hyperledger built on, and things like that. So that is it for this lecture. Please do subscribe for our private coaching sessions as well. I'll see you in the next section. Thank you for watching. Welcome back, everyone. In this section, we are going to look into Hyperledger blockchain ecosystem. So, a little bit of recap about what we have learned in the last session. In the last session, we have learned how blockchain works, what is blockchain structure, what are smart contract, and what are the different types of consensus algorithm. In this section, we are going to have a brief about Hyperledger blockchain ecosystem, where you will see the family Hyperledger and you will see the design philosophy behind Hyperledger, and you will also see the framework architecture. So before getting to the details of Hyperledger family, let me quote what is Hyperledger. So Hyperledger is an open source community focused on developing a suite of stable frameworks, tools, and libraries for enterprise grade blockchain deployment. So it serves as a neutral home for various distributed ledger frameworks, tools, and libraries. So in Hyperledger family, all the projects that are under
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Hyperledger umbrella are divided into four categories which are described here. First is distributed ledger, libraries, tools, and domain specific projects. Now let us see what are the projects that comes under these subcategories. As you can see in the distributed ledger section, you can see you have different frameworks, which is Hyperledger Besu, Hyperledger Bureau, Hyperledger Fabric, Hyperledger Indy, Hyperledger Iroha, Hyperledger Sawtooth. All of these framework serves different purpose. Our main focus for this lecture or this course is Hyperledger Fabric. So we will get more details or much more deeper understanding of Hyperledger Fabric in the coming section. In the libraries subsection, you have the projects like Hyperledger Aries, Hyperledger Quilt, Hyperledger Transact, and Hyperledger Ursa. In tools section, you have Hyperledger Avalon, Hyperledger Caliper, Hyperledger Cello, Hyperledger Explorer. And you also have a domain specific project which is Hyperledger Grid. So this is a curated list where you can see the Hyperledger projects and you can also see the project type, meaning which subsection it falls into, and you can also see the status of those projects, whether those projects are already active or whether they are still in incubation state. If you find these projects interesting, please go through the Hyperledger link where you can explore more about this particular project. The focus of this course is mainly Hyperledger Fabric, which we will get into details in the coming section. What is the design philosophy of Hyperledger? What is the design philosophy meaning? What are its core philosophy where Hyperledger stands on? So the main philosophy Hyperledger stands for is modular technology, and also it has to be open and transparent governance. So because of these design philosophies and a lot of members that are coming in to contribute to Hyperledger as an organization, so many of the companies as listed here has already taken Hyperledger, and they are already working towards including Hyperledger as part of their projects. So if you want more information, you can Google each of these companies and their blockchain involvement with Hyperledger as well. So in Hyperledger blockchain ecosystem, you have Hyperledger framework architecture. So what are the points, or what are the components that framework architecture includes? Some of them are consensus layer, smart contract, database, peer-to-peer networking, and security. So you can go through this slide where you can see the business blockchain component and also key function and responsibility of each of these business blockchain component. So you can see the responsibilities of consensus layer, smart contract layer, communication layer, data store abstraction, crypto abstraction, identity services, policy services, APIs, and interoperation. So all these are the main business blockchain components that has to be taken care when we are trying to design a ecosystem, which is a blockchain ecosystem. So to satisfy various business needs, there are several different consensus mechanisms that is being worked in Hyperledger community. So two major types of those consensus are permissioned lottery-based algorithm and permissioned voting-based algorithm. Each of these types has their own implementation. As you can see, permissioned lottery-based algorithm has proof of elapsed time and proof of work as implementation, and permissioned voting-based algorithm has the redundant Byzantine fault tolerance and Paxos as the implementations. So please go through this slide where you will understand what the different Hyperledger framework which are using different consensus algorithm, and what are the pros and cons of those consensus algorithm. Moving on in this lecture, we are going to have a deep dive into the Hyperledger framework fabric, which is the Hyperledger fabric, and the consensus algorithm that it uses, and what are the pros and cons of the Hyperledger fabric. So this is a small quiz for you to gauge your understanding in this section so far. Please try answering them, and I'll see you in the next section. Please do subscribe for our private coaching sessions as well for greater understanding and personalized lectures. Thank you for watching. I'll see you in the next section. Welcome back, everyone. In this section, we are going to look into components and architecture of Hyperledger Fabric. In the previous section, we have learned about Hyperledger projects, which comes under the subsections distributed ledger framework, libraries, and tools. So, to refresh your memory, Hyperledger Fabric is a distributed ledger framework, and it is intended as a foundation for developing applications with a modular architecture. So, in this section, we will have a deep dive into the components and architecture of Hyperledger Fabric. So, in this section, as we know that we will be looking into architecture and components of Hyperledger Fabric, let us first get to know what are the components that we will be looking into. So here are the list of components that we will be looking into. First one is PO, next is ordering service, Fabric certification authority, Fabric ledger, channel, smart contract or chain codes, endorsement policy, membership service provider or MSP. Now let us go one by one. Now let us look into what do you mean by peer? As you can see from the slide, peer is a fundamental unit of Hyperledger Fabric network. Peer maintains a ledger and a smart contract. Adding to this, peers are fundamental elements of the network because they host instance of ledger and instance of chain code. Each peer can have multiple chain codes and ledgers. Peers have special but chain codes that are always present by default. Peers communicate to each other by using gossip protocol. A single peer is owned by a single organization, hence a single peer is associated with one single MSP. We will learn about what MSP in the later on. So there are different types of peers in Hyperledger Fabric network. First one is anchor peer, then leader peer, endorsing peer, committing peer. So what do you mean by anchor peer? So every organization must have one or more anchor peers so that those anchor peers can communicate to other anchor peers of other organization using gossip protocol. Using anchor peers, the peers in the organization get to know about the peers about other organization, the peers present in the other organization. What do you mean by leader peer? This peer node receives a new block from the orderer and shares it with other peers using gossip protocol. What do you mean by endorsing peer? Endorsing peer has chain code installed on them, and endorsing peers simulate and endorse transactions. What do you mean by committing peers? Committing peers verify endorsement and validate transactional result before committing transaction to the blockchain. Peers can be created, started, stopped, reconfigured, and it can even be deleted. They expose a set of APIs that enable administrators and applications to interact with the services that they provide. Now, let us understand how peers and channels will come together in Hyperledger Fabric network. As you can see from the diagram, if you consider this as the network, which is N that is depicted over here, if you consider this as blockchain network and C as a channel, you have an application A which is connecting to the channel C. So channel is internally connected to P1 peer and P2 peer. Each peer, which is P1 and P2, has the smart contract S1 installed on them, and it has its own ledger, which is ledger 1, which is L1 over here. So this is the simplest form of the network. As we move forward in this section, we are going to complicate the network, and in the end you will get to know how all these components work together. This is the explanation of the previous slide. So peers and applications. So as we have seen, applications are used to connect to peers in the previous diagram. Let us see the definition. So application always connect to peers when they need to access ledgers and chain code. The Fabric Software Development Kit or SDK makes this easy for the programmer. Its API enables applications to connect to peers, invoke chain codes to generate transactions, submit transactions to the network that will get ordered, validated, and committed to the distributed ledger, and receives events when this process is complete. So there are two types where the transaction to and from the peer can be categorized into. One is ledger query and ledger update. We will see what do you mean by ledger query and ledger update in the next slide. Now, as we have seen before in the previous slide, which is you have two types. One is ledger query and ledger update. Let me explain you what do you mean by ledger query and ledger update. As we have seen, ledger query is a 3-step process and ledger update is a 5-step process. Ledger query, in case of ledger query, application connects to the peer P1 which you can see over here, and then application invokes the chain code to P1. Once it is invoked, peer invokes the chain code with the proposal, and chain code generates a query response, and that response will be propagated back to application. So this is the query response that happens between application and peer. When it comes to the other form, which is the ledger update, which is a 5-step process. So application wants to update the ledger instead of querying the ledger. So this is a 5-step process because the application needs to talk to peer, and peer wants to update the ledger. So as part of this process, application connects to peer, then application invokes the chain code. Peer internally invokes the chain code with the proposal. Then chain code generates update proposal response. After that, the response is propagated back to the application. Next, the request of the transaction is sent to the orderer. As part of that, order sends the transaction to the peers in blocks. So orderer takes the transaction, bundles into blocks, and sends it to all the peers. And as part of the next step, peer updates the ledger using the transaction block. After that, the peer sends the ledger update event to the application. So at the end of this, the 5-step process gets completed. So this is the difference between the difference between the ledger query and ledger update. Moving on, so this is the explanation that I have given in the diagram. So you can go through it and please understand the concepts. It's very important to understand the next component and how the network works in its entirety. Now let me explain peers and organization and how they are associated. As you can see, consider this as a network which is represented as N. So as you can see, you have a channel C and you have some circles around it. So from this, what you can get is, so there is P1 and P2 which is connected to the channel, and there is an application A1 as well, and all these three entities are managed by organization 1. It's the same with organization 2 as well. There's application 2. There are three peers, P3, P4, P5. It is being managed by organization 2 and it connects to the same channel, which is C.
Thanks for watching. Please like and share this video.
Then you have another channel which is ARC3 and you have application 3, P6 and P7 which is connected to the channel and it is handled by or managed by organization 3. You have P8 and application 4 which is handled by organization 4. So this is how the channel, application, POs and organization comes together in case of Hyperledger Fabric network. This is the explanation of whatever we have explained in the diagrammatic process. So please go through this. If you don't understand, read through it again until you get it. So in the next session, we are going to look into what do you mean by peers and order, how peers and orderers work together. So ordering service or orderer is an important topic. So we are going to cover that in detail. So after those sessions, it will be clear for you that how peers and orderers communicate with each other. Next is peers and identities. Peers have an identity assigned to them via a digital signature or digital certificate from a particular certification authority. Each and every peer in the network is assigned a digital certificate by an administrator from its owning organization. So we will cover what is this certification authority and the related topics like MSP in the coming section. But for time being, you should know the peers and identities are always associated together. That is it for this lecture. So we are going to look into ordering service and how it is related to peers and how it's going to affect the fabric network in the coming lecture or in the next lecture. So thank you for watching. I'll see you in the next section. Welcome back, everyone. In this section, we are going to look into another important component of Hyperledger Fabric, which is ordering service. Ordering service, sometimes also called as orderer, and why this ordering service is needed. What is the mechanism behind the ordering service comes into picture. The mechanism by which applications and peers interact with each other to ensure that every peer's ledger is kept consistent with each other is mediated by special nodes called orderers. So there are different types of orderers as you can see here. First one is Solo, second is Kafka, next is Raft. In Solo, you have one single orderer, and in Kafka, you can have a cluster of orderer. And Raft is a newly introduced ordering mechanism which is recommended from version 2.0. The Solo and Kafka is deprecated from version 2.0. So if you are starting with a project, then it is recommended that you have to go with the Raft, which is from version 2.0. Now let us look into the ordering service and how it works and where it stands in a Hyperledger Fabric point of view. So orderer automatically broadcasts messages containing transactions to peers to be committed. All peers receives the same block of transaction in the same order. The ordering service orders transactions on first come first base, which is FIFO mechanism for all channels on the network. After the transaction is ordered, the records are put into a block, meaning the transactions are put into the block for that communication channel. So as you can see from this slide, you can come to a conclusion that orderer is responsible for getting all the transactions and blocking it or bundling it as a block, and the communication takes place from that point. So as we have already seen in from the peer structure, there is a difference between update and query transaction. So when it comes to update transaction, we need to go through a process called consensus. Let us look into that more in detail. An update transaction is quite different from transaction like query transaction because a single peer cannot on its own update the ledger. Updating requires the consent of other peers in the network. So a peer requires other peers in the network to approve a ledger update before it can be applied to peer's local ledger. And this process is called consensus, which takes much longer to complete than a simple query. This means that when you do a query transaction, from any peer you can get the output, which means the consensus is from all the peers are not required for a query transaction. But when it comes to update transaction, the consensus from all the peers is required, and that is why that the process of that consensus has to happen among all the peers, and this takes more time when compared to a simple query transaction. So, how this consensus happens? So, the consensus happens in three phases. So, these are the three phases that you have to go through for updating the ledger in Fabric. So, this is taken care by orderer itself in Hyperledger Fabric. Now, let us see the phases. In the first phase, applications work with a subset of endorsing peers, each of which provide an endorsement of the proposed ledger update to the application, but do not apply the proposed update to their copy of the ledger. So, in the first phase, what happens? When the application sends a transaction, update transaction to the endorsing peers provides endorsement and proposed ledger update back to the application. At this point of time, the peers do not apply the update to their copy of the ledger. This update happens after the third phase, which we will see next. So, in the second phase, these separate endorsements are collected together as transactions and packed into blocks by orderer. In the third and final phase, these blocks are distributed back to every peer where each transaction is validated before being committed to the peer's copy of the ledger. As I told in the first phase, when the proposed ledger update happens from peer to the application, at this point the peers don't update their ledger. In the third phase, when it receives the block and that block is circulated by the orderer, at that time each transaction is validated and later it is committed to the peer's copy of the ledger. These are the phases that has to go through for updating the ledger in Fabric. So the three phases that we have discussed in the last slide, along with the below topics, are covered in depth in our course material, which is orderer nodes and channel configuration, orderer nodes and identity, orderers and transaction flow, orderer service implementation, which is raft. We will also see the lab implementation, like what are the channel configuration file and where exactly we need to write the code and all that in the practical section. So in addition to ordering role, orderer also maintains a list of organizations that are allowed to create channels. This list of organization is known as consortium, and the list itself is kept in the configuration of the orderer system channel, also known as ordering system channel. We will look into orderer system channel in practice, which is inside a configuration file. So we will look that in the practical section. So orderer also enforce basic access control for channel, restricting who can read and write data to them, and who can also configure them. Remember that who is authorized to modify a configuration element in a channel is subjected to the policies that are relevant to administrators set when they create the consortium or the channel. So we will look into how we are going to create the consortium and how we are going to create the channel and how we are going to specify the policies and administrators when we actually bring up the network. So this is detailed in the practical section. Now we have, as we have mentioned before, we have Solo, Kafka and Raft. And Solo is mainly for testing purpose where you have only one orderer node. The main competition comes between Raft and Kafka for the production level network. Now let us see which one is better or which one is more supported in Hyperledger Fabric. So Raft is easier to set up. Kafka and Zookeeper are not designed to be run across large networks. Raft is supported natively, which means that users are required to get the requisite images and learn how to use Kafka and Zookeeper on their own. This means that after 2.0, Raft is supported natively. You also get the image of that when you try to download Hyperledger Fabric supported images. So if you want to set up Kafka and Zookeeper, you have to learn it on their own. It doesn't come with the images from 2.0 because it's going to be deprecated. The Solo and Kafka will going to be deprecated from version 2.0. So that is why it is recommended to go with Raft. Whereas Kafka uses pools of servers, which is also called Kafka brokers, and the admin of the order organization specifies how many nodes they want to use on a particular channel, Raft allows the user to specify which ordering nodes will be deployed to which channel. Raft is the first step towards Fabric deployment of Byzantine fault tolerance ordering service. So we've learned about what Byzantine fault tolerance before. Please visit those lectures if you are unclear with it. So Raft is the first step towards solving this problem. So it is recommended that you go with Raft and the implementation details of the Raft will be given to you or explained to you in the practical section. That is it for this lecture. In the next lecture, we are going to look into one more component, which is Fabric Certification Authority. See you in the next section. In this section, we are going to look into another component, which is Fabric Certification Authority. Before getting to Fabric Certification Authority, there is a term which is Public Key Infrastructure or PKI. So a public key infrastructure or PKI is a collection of internet technologies that provides secure communications in a network. So if you see the diagram that is shown here, so the PKI infrastructure constitutes the certification authority and other internet technologies as well to provide secure communication. So as you can see here, so you have a user, so you are the principal who request for the certificate, right? So and once he requests for the certificate, the certification authority will issue the certificate for that person, and that person can identify himself or herself using the public and private key which is provided by the certification authority. So the certificate authority is also responsible for certificate revocation list. So we'll look into what certificate revocation in the next slide. So Fabric Certificate Authority. So the elements of public key infrastructure, as we have seen before in the picture, a PKI is comprised of certification authority who issues digital certificate to parties, for example users, who then use them to authenticate themselves in the messages they exchange in their environment. A certification authority's certification revocation list, which is the CRL, constitutes a reference for a certificate that are no longer valid. So revocation of certification certificates can happen for a number of reasons. For example, a certificate may be revoked because the cryptographic private material associated to the certificate has been exposed, or many other reason, whether the certificates may be expired or something of that sort. So in that case also, a certification authority can revoke the certificate.
Thanks for watching. Feel free to add your questions as comments down below.
So when it comes to Fabric Certification Authority or Fabric Certificate Authority, it is a private root certification authority provider capable of managing digital identities of Fabric participants that have the form of X509 certificates. Because Fabric CA is a custom CA targeting the root CA needs of the Fabric, it is inherently not capable of providing SSL certificates for general or automatic users in the browser. So the concepts like this, like digital identity, public key infrastructure, digital certificates, authentication and revocation are more covered in depth in the course material. And we will also look into how we are going to integrate the Fabric Certification Authority into our network in the practical sections. So coming to Fabric Certification Authority again, so it is a custom implementation of certification authority, which we have seen in the PKI system, and it is an alternative to Cryptogen. So as you have, if you know a little bit about Hyperledger Fabric already, we know that a Cryptogen will give you the certificates for a particular peer or for a particular entity in Hyperledger Fabric. So this acts as an alternative. The Fabric Certification Authority acts as an alternative for Cryptogen tool, and it helps in registration of identity in the network and also enrollment of that identity to the network. So this is about Fabric CA. In the next lecture, we are going to see what ledger is in Hyperledger Fabric. See you in the next section. In this section, we're going to look into another important component, which is ledger. So ledger stores important information about business objects, or also known as assets. So ledger consists of two parts. One is world state and the other one is blockchain, which is nothing but a transactional log. So the world state has two database options. One is level DB, which is default in Hyperledger Fabric. Then you have another option, which is CouchDB, where you can run rich data queries. So the ledger is a sequenced, tamper-resistant records of all the state transitions in the fabric, while state transition are a result of chaincode invocations or chaincode transaction invocation submitted by participating parties. Each transaction results in a set of assets, which are key value pairs that are committed to the ledger as the create, update, and delete transaction goes on. So the ledger is comprised of blockchain to store immutable sequenced record in blocks, as well as a state database to maintain the current fabric state. So there is one ledger per channel. Each peer maintains a copy of the ledger for each channel of which they are a member of. So query and update ledger using key-based lookups and range queries and composite keys are possible. So read-only query is using query-rich language. So if you are this can be used if you are using your CouchDB as your state database. So CouchDB is really good if you include it in your project, where you can actually run rich queries on the CouchDB. So you can also get the history of a particular asset by running read-only history queries. So query ledger history key for the history for a key enables data provenance scenario. So using a key of an asset, you can get the details of an asset, what all the states or what all the stages that asset has been through. So you can get the history of that particular asset. Next, you have transaction consist of versions of key or value or key value pairs that were in a that were read in a chain code. So that is called read set, and the key value pairs that were written in the chain code is called write set. So the transaction contains signature of every endorsing peer and are submitted to ordering service. The transactions are ordered into blocks and are delivered from an ordering service to peers on a channel. Then, after that process, peer validates the transaction against endorsement policies and enforces the policies. So, prior to appending a block, a versioning check is performed to ensure that states of an asset that were read have not changed since the chain code execution time. So, there is an immutability once a transaction is validated and committed to the blockchain. So a ledger contains a configuration block defining policies, access control list, and other pertinent information. So the channels contain membership service provider or MSP instances, allowing for crypto materials to be derived from different certification authorities. In this picture, as you can see, you have a peer which is peer 1 and it has different smart contracts deployed on it and it has different ledger. As you can see, you have smart contract 1 and smart contract 1 again, and you have smart contract 2. So you may ask why the same smart contract S1 is deployed on the same peer and it has different ledger. As we have seen before, for every channel, peer keeps a different ledger. So that is the reason you have two ledger, which is L1 and L2. This means this peer P1 is part of two channels, which is maintaining different ledger. One channel for the ledger, one ledger L1 for channel 1 and another ledger L2 for channel 2, and the both the channel has the same contracts, same smart contracts installed on it. So you have this smart contract ES2 which has not generated any ledger so far. So this is not yet invoked by any client or any application. So that is it for the ledger section. In the next section, we are going to look into another component which is channel. See you in the next section. Welcome back again. In this section, we are going to look into a component which is channel. So channel is a mechanism by which interested peers within a blockchain network can collaborate and communicate. A Hyperledger Fabric channel is a private subnet of communication between two or more specific network members for the purpose of conducting private and confidential transaction. So we have system channel and also application channel. A channel is defined by members or organizations, anchor peers per member or organization, a shared ledger, chain code application, and ordering service node. Each transaction on the network is executed on a channel, where each party must be authenticated and authorized to transact on that channel. Each peer that joins a channel has its own identity given by a membership service provider, which authenticates each peer to its channel peers and services. The election of leading peer or leader peer for each member or each organization on the channel determines which peer communicates with the ordering service on behalf of the member or the organization. No ledger data can pass from one channel to another channel. This separation of ledgers by channel is defined and implemented by the configuration chain code, the identity membership service provider, and the gossip data dissemination protocol. Now let us see how you can create channel. To create new channel, the client SDK calls configuration system chain code and references properties such as anchor peers and members of the organization. This request creates a genesis block for the channel ledger which stores configuration information about the channel properties or channel policies, members, and anchor peers. So in the practical section, we are going to see how we can create this Genesis block, and I'll also show the content of this Genesis block. When adding a new member to the existing channel, either this Genesis block or, if applicable, a more recent reconfiguration block is shared with the new member. The, the channel and its detailed configurations are covered in depth in the course material and also in the lab as well. So as we have seen, we need to create something called Genesis block. So we also have a different tool which is called config tx. So we are going to see how we can use this config tx and how we are going to generate Genesis block in the lab section. So this is just an introduction for that lab process. So channel configuration or config tx has the following important property. That is, it is version, meaning all elements of the configuration have associated with the version which is advanced with every modification. It is permissioned. Each element of the configuration has an associated policy which governs whether or not the modification to that element is permitted. Then you have hierarchical. A root configuration group contains subgroups, and each group of the hierarchy has associated with values and policies. These policies can take advantage of the hierarchy to derive policies at one level from the policies of lower level. We will understand all these policies deriving and why it is versioned and how it can provide permissions and all those details when we use this config tx tool to generate the Genesis block and much more channel details. So that is it for this lecture. In the next lecture, we are going to see what are smart contracts. Thank you for watching. Welcome back. In this section, we are going to look into smart contracts. In this section, we are not going to have deep dive into smart contracts or how to write smart contract and the implementation details. We do have a dedicated lecture on boot camps for writing the smart contracts and the implementation details. Please do subscribe for that course in order to get the understanding of the smart contract and detailed understanding of the implementation details. This is just a introduction to what smart contracts are. So smart contracts are nothing but business agreement encapsulated in the code. So what is the difference between smart contract and chain code? So smart contracts are meant to contain certain logic that gets executed and interacts with the ledger in order to manage and maintain the state of the asset. So chain code governs the administrative aspect of the smart contract. That is how smart contracts are packaged in a chain code and then deployed on the network. So from this, you can understand that you can have many smart contracts inside a chain code, and chain code is a packaged version which you can deploy it on the network. Now we will see how exactly this smart contracts evolves, or what is the process that is involved when somebody invokes the transaction. So now you have a chain code which is deployed on the network. So when the transaction request comes, so you have the contract ID and the transaction dependencies that are part of that particular transaction exists, and you also see the current state. So all these actions takes place in a peer. So it looks at the peer looks at the contract ID and the transaction dependencies and also the current state of the ledger which is present in the peer. After that, after the transaction request process, the smart contract interpreter process the request. So during this process, the peer checks the current state of the ledger, and it also checks the business logic or the code that is associated with that smart contract. Once this process completes, you will get the output, and based on that output, you can also say that the results or the output contains the delta state, which is the ledger state that was before this transaction processing and after transaction processing. And it also contains other details like the correctness attestation and also the ordering information. This is in brief how the contract interpreter processes the request. So much more details are covered, and the implementation details and the coding part is covered in a different lecture or in a different course. Please do subscribe for that course in bootcamp.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
For this lecture, that is it. Thank you for watching. In the next lecture, we are going to see what are fabric policies. See you in the next lecture. Welcome back, everyone. In this section, we are going to look into fabric policies. So policies are implemented at different level in Hyperledger Fabric network. Each policy domain governs different aspect of how a network operates in Hyperledger Fabric. This is a pictorial representation of Hyperledger Fabric policy hierarchy. At the top, you have system channel, which governs consortium membership and blockchain structure. You have application channel and at the next level, which governs transaction network and business logic. You have ACL and smart contracts, which governs transaction, data, and events. We will look at each of these in detail. First is system channel configuration. Every network begins with an ordering system channel. There must be exactly one ordering system channel for an ordering service, and it is the first channel that will be created in your system or in your network when you do the configuration. The system channel also contains the organizations who are members of ordering services and those that are on the network to transact, which are nothing but consortium organization. Next comes application channel configuration. Application channels are used to provide a private communication mechanism between organizations in the consortium. The policies in an application channel governs the ability to add or remove the members from the channel. Application channel also governs which organizations are required to approve a chain code before the chain code is defined and committed to a channel using the Fabric chain code lifecycle. We will look into Fabric chain code lifecycle soon. Next comes in the hierarchy is access control list or ACLs. Network administrator will be interested in this Fabric use in this access control list, which provides the ability to configure access to resources by associating those resources with existing policies. Access control list refers to policies defined in an application channel configuration and extends them to control additional resources. The default set of Fabric ACLs is visible in context.tx.yaml file under this section, which is named as application. So here this section should be overridden for your different environment. When we go to the lab section, I'll show you what this config.tx YAML comprised of, and I'll also explain in detail what this application section holds. So continuing on ACL, the list of resources named in config.tx.yaml file is the complete set of all internal resources currently defined by Fabric. In fact, in that file, ACLs are expressed using the following format. So you just have to remember this for time being, because since we are going through the theory section, you just have to keep a note of this, that this is the piece of line that we will write as ACL policy for chain code 2 chain code invocation. When we go to the lab section, you will see the usage and where and how we are going to write this and how it is associated with the network configuration. As you can see here, the peer slash chain code to chain code, it represents the resource that is being secured, and this the right hand side part, which is the value part, slash channel slash application slash readers, refers to the policy which must be satisfied for the associated transaction to be considered valid. Next, we will move on to something called fabric policy domains. While fabric policies are flexible and can be configured to meet the needs of a network, the policy structure naturally leads to a division between domains governed by either ordering service organization or members of the consortium organization. So Hyperledger Fabric policy hierarchy is covered in depth in your course material as we move forward. So in the next diagram that I'm going to show you, you will see how default policies implement control over the fabric policy domains. If you can see this structure, this explains Hyperledger Fabric policy hierarchy. The left side which you see in this partition, you can see what orderer organization is governed by. I mean, what orderer organization can keep a track of. And also in the right side, you can see what consortium organization governs. As you can see, order organization governs the system channel, application channel, and consortium organization governs other part of the specific channel specific details like channel modification, channel membership, organization policies, smart contract, ledger data, and events. So how do we write a policy in Fabric? So if you want to change anything in Fabric, the policy associated with the resource describes who needs to approve it, either with an explicit sign off from the individual or an implicit sign off by a group. In Hyperledger Fabric, explicit sign-off in policies are expressed using the signature syntax, and implicit sign-offs use implicit metadata syntax. So you should keep that in mind that there are two types of signatures that you can expect in Hyperledger Fabric. One is signature and the next one is implicit metadata. Let us look at the signature policy. Signature policies define specific types of users who must sign in order for a policy to be satisfied, such as or organization1.peer or organization2.peer. So I'm going to explain more in detail in example in the coming section. So for time being, you have to remember that in signature policy, this is what the syntax should be. And this policy defines that the organization 1 peer or organization 2 peer have to approve this. So the user belongs to this particular organization must sign in order for a policy to be satisfied. So these policies are considered the most versatile because they allow the construction of extremely specific rules like an admin of organization A and second admin of organization B and some random admins of any organization that are present in the network. So moving on to implicit meta policies, which is the second type. So implicit meta policies are only valid in the context of channel configuration, which is based on tiered architecture, tiered hierarchy of policy in a configuration tree. Implicit meta policy aggregate the result of policies deeper in the configuration tree that are ultimately defined by signature policies. That means implicit meta policy implicitly uses signature policy. The following diagram, which I'm going to show in the next slide, will going to show you how a tiered policy structure for an application channel works, and it also shows the implicit channel configuration admin policies, and you can also see the named channels or admins is resolved, and when it is resolved, the sub-policies named admin below it configurations are satisfied, where each check mark represents the condition of sub-policies were satisfied or not. So I'll again explain it to you in detail in this slide. So as you can see in this tree, you have application channel as the root of the tree, and you have channel or application slash admin for the as a children of this particular node. So you have two children, as you can see. One is channel slash application slash admins, and another one is channel slash orderer slash admin. For channel slash orderer slash admin, you have channel orderer and orderer organization admin. So you have only one admin which is taking care of this orderer MSP or orderer node. In the channels application slash admin, you have organization 1 MSP and organization 2 MSP. So application channel comprises of two two organization. One is organization 1 and organization 2. So the the subscript that you see here, like type is equal to 1 and type is equal to 1, type is equal to 3, which you can see here. So that represents whether it is an implicit meta policy or signature policy. As you can see here, at the child node or the leaf node of this hierarchy, you can see it is a signature meta policy. As you move ahead in the towards the root of this tree, you can see it is an implicit policy. In the previous section, I have also told that implicit meta policy also uses signature policy in its core. So this is the proof of it. So as you can see, the leaf nodes has signature policy, is using signature policies, and implicit policy is used by the root nodes. So let us move on to what do you mean by endorsement policy. So endorsement policy is nothing but it defines the smallest set of organizations that are required to endorse a transaction in order for it to be valid. It describes a set during chain code instantiation. So this is described or set during the chain code instantiation. So principals are described as MSP.role, where MSP represents the required MSP ID or role, and role represents one of the four accepted roles, which is either member or admin or client or a peer. So we are going to look into this MSP role in detail, also in a lab section and in couple of examples in the coming slides as well. Now let us look into the couple of examples over here. So here are the few examples for valid principles. So org0.admin means any administrator of organization 0 which is holding that corresponding MSP. And organization 1.member means any member of org1 MSP. And org1.client means any client of organization 1 MSP. Organization 1.peer means any peer of organization 1 MSP. And the syntax for this language is the expression followed by, as you can see here, expression is nothing but and or out of or e. Sorry, this expression takes three values, which is and or out of, and e is either a principal or it is another nested expression. So if you get confused with this syntax, don't worry. I'm going to explain and give examples as well to write the endorsement policy as a syntax. So here are the examples that I've told you in the previous section. So you have this expression. So as I told, it takes three values. Two of them are described here. One is and or. So and let's look at this expression which you see here. And open brace organization 1 dot member, organization 2 dot member, organization 3 dot member. This statement means it requests one signature from each of the three principals, which means all of the principals that are mentioned here, which is organization 1 member, organization 2 member, and organization 3 member, all of these signatures are required. Next, This statement shows that it requires one signature from either of the two principals, which means you need either signature from org1 or org2. The third one represents the nested expression that we have talked about. This means it requires either one signature from a member of org1 MSP or one signature from a member of org2 MSP and one signature from a member of org3 MSP. It is just like the and or that we usually follow in any computer science activity. So this is how
Thanks for watching. Please like and share this video.
endorsement policies are written as a statement. So we will look into the details when we go into the configuration files in the lab section. So just to give a quick overview, so this is how the configuration file looks like in case when we are setting up the Fabric network. So as you can see here, the policy section, sorry. Yeah. As you can see the policy section over here, you have readers, you have writers, you have admin, and you have endorsement. Here you will find the rule, and here you will also find the type of the rule. For time being, we have taken an example of signature rule. So here, as you have seen in the previous section, this requires either org1 MSP, org1 MSP's peer, org1 MSP's admin, or org1 MSP client. Like one of the signature is required for this rule to be satisfied, and it's the same for other policies that we have mentioned here. We will look into each of this when we go to the practical section. Here we will see the channel configuration policy example. So keeping in mind whatever we have seen in the last piece of code or piece of that particular slide. So in that slide, you have each organization definitions or have the certain default policy for that organization, which are nothing but readers, writers, admins, and endorsement. Although you can also get your own custom names as well. So each policy has a type which describes how policy is expressed. That is what we have seen as part of signature and implicit metadata, and a rule that we have seen with example. So in the previous slide, as we have seen the organization one definition in the system channel, where the policy type is a signature type and the endorsement policy rules defines as or organization one MSP.peer. So let's go back to this. So as you can see here, the endorsement policy here org1 MSP.peer. So this means this policy specifies that the peer that is a member of org1 MSP is required to sign. So if these signature policies that become sub policies, that the implicit metadata points to. So as we have seen the tree structure, implicit metadata policy is at the root and it implicitly uses the signature policies. So as part of the transaction validation, couple of the steps has to be performed, and those steps are each validating peer checks to make sure that the transaction contains appropriate number of endorsements. The transactions are from the expected sources, which means both of these are specified in the endorsement policy. We will see that in the practical section, the files and the endorsement policies and all that. And the endorsements are also checked to make sure that they are valid. That means they are having valid signature from valid X509 certificates. So the way to set the endorsement policies in Fabric is setting chain code level endorsement policy. We can also set collection level endorsement policy. You can set key level endorsement policies as well. So we also cover all this information in another course which is called Hyperledger Fabric for Developer course. If you wish to learn more, please do subscribe to that course as well from bootcamps. We do have something called private data. So for private data collection, you can also specify an endorsement policy at the private data collection level, which would override the chain code level endorsement policy for any keys in the private data collection. So there are cases where it may be necessary for a particular public channel state or private data collection state to have different endorsement policy. This state-based endorsement allows the chain code level or connection level endorsement policy to be overridden by different policy for a specified keys. So we will cover both of these in depth as I mentioned in the previous section. So we cover this in Hyperledger Fabric for developer course. Please do subscribe for that course as well to get more information or in-depth knowledge of these endorsement policies. So that is it for this lecture. Please go through the lecture if you don't understand something about these policies. But if you don't understand, it's totally fine, because when we do the lab section, you will get a brief understanding or in-depth understanding of how it's going to work. That is it for this lecture. Thank you for watching. In the next lecture, we're going to see what MSPs are. Thank you. Welcome everyone. In this section, we are going to see what membership service provider is. A mechanism that provides members with a set of roles and permissions within the network is the responsibility of membership service provider. The implementation of MSP requirement is a set of folders that are added. So these folders contains the private and public key for each of the entities that are present in the network. It has two types, which has local MSP and channel MSP. So let us see the association with MSP and certification authority. Certification authorities issues identities by generating a public and private keys, which forms a key value pair that can be used to prove the identity. Because a private key can never be shared publicly, a mechanism is required to enable the proof, which is where the MSP comes in picture. For example, a peer uses its private key to digitally sign or endorse a transaction. So the MSP is a mechanism that allows that identity to be trusted and recognized by the rest of the network without ever revealing the member's private key. So this is where MSP and certification authority or certificate authority goes hand in hand. So certificate authority generates the certificates that represents identities. The MSP contains the list of permissioned identities. Also, it is MSPs that turns an identity into role by identifying specific privileges of an actor that has a node or a channel. So note that when a user is not registered with a Fabric CA, a role of admin, peer, client, orderer, or member must be associated with the user. So these are the default roles that we have seen in the previous lecture. So when a user is registered, this has to be one of these has to be associated with the user. So this is about MSP, which is a short lecture. So please go through the MSP, and when we go to the practical section, where the lab section, we are going to see where actually the public and private key resides, and how the program or the Hyperledger network picks up that and uses as an identity to recognize a particular entity or a user in the network. That is it for this lecture. I'll see you in the next lecture. In the next lecture, we are going to look into Hyperledger Fabric network, and we are going to see the formation of Hyperledger Fabric network step by step. That is it. Thank you for watching. Welcome back, everyone. In this section, we are going to look into Hyperledger Fabric network creation step by step. A Fabric permission blockchain network is a technical infrastructure that provides ledger service to application consumers and administrators. In most cases, multiple organizations come together as a consortium to form the network, and their permissions are determined by a set of policies that are agreed to by the consortium when the network is originally configured. So in the following slides, I'll take you through the decisions that organization will need to make to configure and deploy a Hyperledger Fabric network, and also to form a channel to transact within the network, and how to update these decisions in the life of the network. So please revisit this slide once you understand the process which I'm going to explain in the next particular steps. So basically, to summarize this slide, we have organization RA, RB, RC, and RD who have decided to jointly invest in a Fabric blockchain network. So organization RA will contribute 3 peers and two client applications, and RA will consume the services of blockchain network. And organization RB will contribute 4 peers and has one client application. Organization RC contributes 3 peers and has two client application. And organization RD contributes four orderers or order peers. So organization RA and RB have decided to form a consortium and exploit a separate application channel between the two of them. So organization RB and organization RC have decided to form another consortium and also exploit the separate application channel between the two of them. So each of the application channel has its own policy. So as I've told you before, please do revisit this whenever it is needed while I'm explaining the next slide. So from next slide, I'm going to explain it to you how the network will get formed in an incremental fashion. So let us consider this as a fabric network that we are going to build. So first thing that we need for a network is an orderer. As you can see here, you have one orderer which is facilitated by the certification authority 4, and it is governed by the organization RD, and it has to adhere to the policies that are mentioned here, which is network policy 1. So this is the first step in creating the network. As part of second step, RA and RB, that is organization A and organization B, has come forward to form a consortium. For that, organization A as facilitated by the certification authority CA1 to give the certificates to RA, and organization B is facilitated by certification authority 2 to get the certificates. Now, creating a channel for consortium. In the previous slide, you can see that RA and RB has created the consortium X1. Now, in order for them to take place in the communication in a private manner, channel is needed. So they create the channel which is in turn connected to orderer, and this channel has to abide by the channel policy 1 rules, which is agreed by both RA and RB, which is organization A and organization B. So channel 1 is connected to both RA and RB. Here we are adding one peer to the channel. So as you can see here, peer 1 is again facilitated by certification authority 1 to get the certificates to identify himself or herself or that node to the channel. And this is governed by organization A. Now comes the application and the smart contract. So application A1, which is facilitated by certification authority 1 and also governed by organization A, is connected to channel 1, which you can see here, and that in turn is connected to peer, which holds the smart contract ES4, and it has a ledger L1 for this particular channel. Next, growing the network. This means in the previous section, you have seen you have only P1 as a peer, which is governed by organization B. In the next step, RB or organization B decides to contribute one peer to the network or to the channel. So that's why RB contributes P2 as the as the node that it governs, and application A2 to talk to the channel in order to access the peer information that are present in peer. And the same smart contract has been deployed, that is S4, and the ledger for that uh, particular node P2. And here A1 application 1 is governed by organization A and application 2 is governed by organization B, as well as P2 is also governed by organization B. Next, next in the process, RB and RC comes together and forms another consortium in the existing network. So as you can see here, in the previous section, we had only one consortium, which was X1.
Thanks for watching. Feel free to add your questions as comments down below.
In this slide, you have one more consortium, which is X2, which constitutes RB and RC partnership. Moving on, to communicate the transactions or to communicate privately, we need another channel for this consortium, which includes organization B and organization C. So that is why we have channel C2, which is connected to an orderer node, and it has to abide by channel policies 2, which is already agreed by organization B and organization C. So this channel C2 contains uh, it facilitates the channel policies that is agreed by organization B and organization C. And moving forward, organization B and organization C can bring in their peers, which can connect to C2, and they can also bring in applications that can connect to C2. That we will see in the next section. Sorry, next slide. So in here, as I told, C2 is governed by RB and RC consortium, and A3 is an application that is governed by RC again, and RC is contributing a peer P3 and it is connected to channel C2. So the smart contract that is deployed is S5, and the ledger that the peer is maintaining for this channel, which is C2, is L2. Next, joining a peer to multiple channel. As we have seen in the previous section, P2 was part of the channel C1. Now, organization B decides that P2 will be part of both channel C1 and C2. So that is why you can see it in the picture that P2 is connected to C2 as well, which is channel 2. Now, this is a fully formed network which combines both the channel creations and everything else that we have talked in the previous slides. I'll summarize anyway. So as you can see here, you have two consortium. One consortium contains organization A and organization B, and another consortium contains organization B and organization C. Each of the consortium has to abide by their own rules, which is the channel policy 1 in case of consortium RA and RB, and channel policy 2 in case of consortium organization B and organization C. So you have two channels, which is C1 and C2, and you have three application A1, A2, A3. You have four certification authority. You have one orderer node, and you have three peer nodes. As you can see from the figure, certification authority A is facilitating the certificates for A1, P1 and organization A, which means organization A relies on certification authority A1 to get the certificates for the entities that are participating in the network on behalf of organization A. And it's the same thing for both organization B and organization C as well. So that relies on this particular color coded certification authority to get the certificates for the entities that participate in the network. And you have an orderer node that is handled by organization D, and it has to abide by the network policies that are decided here. As you can see here, the channel C1 has two peers, which is P1 and P2, because the consortium formed by RA and RB participates in the has formed the channel C1, and it has connected to P1 and P2, and application A1 and A2 can connect to this channel C1, and it can execute the smart contract, and that particular ledger you can see it in L1. As you can see, you have S4 and L1, and P2 has S4 and L1 as well. Next you have C2 channel, and C2 channel is connected to P3, and it is also connected to P2 as well. As you can see from this structure, one peer, which is P2, which is part of organization B, is part of both channel 1 and channel 2. That is why it has two smart contracts and it has two separate ledger for maintaining the data that is there for that particular channel. So to summarize this, a peer can be part of two different channel, and when a peer becomes a part of two different channel, it maintains two ledger for each of this is particular to one particular channel. So that is how it goes. So from this you can understand how different entities come together as different entities and forms a network. So if you have any doubts in this section, please do revisit in order to understand this completely. This explains how the network is formed. So as this in this slide you can see the explanation that I have explained in the previous diagrams in the previous slide. So if you don't understand, please read this again and again until you understand this, because it's very much necessary. That is it for this lecture. In the next lecture, I'm going to explain you the installation requirements for setting up the Hyperledger Fabric network. See you in the next lecture. Thank you for watching. Welcome back again. In this section, we are going to look into installation requirements needed for Hyperledger Fabric. So the installation requirement for Hyperledger Fabric depends on the operating system that you will be using. So depending on the operating system that you will be using, you have to install different packages and the softwares that is needed by Hyperledger Fabric. So I've already installed all those packages in my system. So I'm gonna tell you how it's gonna look like, and how you guys can verify whether all the packages required by Hyperledger Fabric is installed or not. So let me go through one by one what all the packages or the softwares that you have to install for Hyperledger Fabric. First, you need to install Git, and then you need to install CORL. Then you have to install Docker and Docker Compose as well. Then you have to install Go, and then you have to install Node.js and NPM package manager, which is Node Package Manager. So these are the requirements for Linux OS. But if you are working with Windows OS, then you have to install Python as well, because Python doesn't come out of the box in Windows. So you have to install Python explicitly, and you also have to install some Windows extra items for the Windows to support Docker and Docker Compose. And it's the same for Mac OS as well. So for Mac OS also, we need to see you need to follow the same procedure like the way you follow with Linux. So there's not much difference between Linux and Mac. But for Windows, you have to explicitly install Python, and you have to go through a procedure where you can facilitate Docker in Windows. So now let me go and let me show you how it looks like when you install these in your machine. So I have already installed all those softwares and packages in my system, and I am using Mac OS. So let me just execute this command. So once you guys install all those softwares that I've listed, please do go and try executing these commands as well to cross verify the successful installation of all those packages and softwares. So first let me go and see whether the curl is there. So I have curl and I have npm as well, and let me go and check the Docker version. So before checking the Docker version, you have to see whether your Docker is up and running or not. Then let me go and check Docker Compose, Docker Compose version. So I have Docker Compose version installed. Then I'll check Go version. I have Go and Python. I don't need to check this because mine is Mac OS, but if you are using Windows, you have to cross check again. Then check whether Node is installed and also check the Git version, because Git is where we will be downloading the sample code from. So you have Git version as well. So these are the packages that you need to keep in mind when you are trying to install all the dependencies as well. Um, so that is it for this lecture. And in the next lecture, we are going to look into application lifecycle management. As part of that process, we are going to look into installing and instantiating the Chaincode package and configuring endorsement policies, defining collection policy for private data, and how to modify and upgrade the Chaincode. So that is it for this lecture. We do have private tutoring session for more one-to-one interaction and one-to-one guidance. Please do subscribe for private tutoring session from Coding Bootcamps. That's it for this lecture. I'll see you in the next lecture. Thank you. Welcome back, everyone. In this section, we are going to look into application lifecycle management. In the previous section, we have learned the different components of Hyperledger Fabric and how those different components come together and form a Hyperledger Fabric network. Since we have a good understanding of how Hyperledger components work and how they form a Hyperledger Fabric network, we are ready to go and understand the application lifecycle management. In this section, we are going to look into how to install and instantiate Chaincode package, how to configure endorsement policy, and how to define collection policy for private data, and how to modify or upgrade Chaincode. Coming to the first part, which is install and instantiate Chaincode package. As we know, we can write multiple smart contracts, and all those multiple smart contracts are bundled into a chain code, and we have to install and instantiate on our network. So now let us get into the two commands which are used to installing and instantiating chain code on the Hyperledger Fabric network. Let us see the first command, which is pure chaincode install command. So as you can see in this command, pure chaincode install, you have -n, which says the name of the chaincode, and -v is the version of the chaincode that has to be installed, which we have specified as v0, which is version 0, and -p is the path of the chaincode. So this is the command that is used to install the chain code on the network. Moving on to pure chain code instantiate. So this is the command that is used to instantiate the chain code on the network. Now let us understand the meaning of all these arguments that we are passing. Pure chain code instantiate, then you have -o orderer. This -o option tells the ordering service endpoint. So what do you mean by endpoint? Endpoint is nothing but a place where that orderer service is running. Then you have -c my channel. This tells the channel ID. So this is the channel on which this command should be executed. Then you have -n, which is the name of the chain code. Then again you have -v, which is the version of the chain code that we have already mentioned in the chain code install command. Then you have -c, which represents the constructor message for chain code in JSON format. As you can see, when you take an account from this brace to this curly brace, this is a JSON format. The default is an empty close and opening and closing parenthesis, which provides no arguments at all. So, but here we are providing different parameters. As you can see here, we are providing arguments, which is an array, and it contains different parameters, which are nothing but the name of the function that we are calling and the parameters that we are going to pass to that function. And you have CA file, and this is a path file which contains the PEM file. So this is the PEM file is nothing but the encoded trusted certificate for ordering endpoints. And you have the last option, which is TLS, which means you have to use the TLS when
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
communicating to the orderer endpoint. So there are other options as well. You can visit the documentation of Hyperledger Fabric if you want to use or if you want to know some more options that are available in the for all these particular commands. So moving on to endorsement policy. How do you configure endorsement policy? So by default, endorsement policies are specified in the chain code definition, which is agreed to by channel members and then committed to a channel. That is, one endorsement policy covers all of the state associated with the chain code. So we have to configure that in config.tx.yaml file. Although we have already mentioned or we have already learned about the config.tx file, I want to show you how and where this organization and application comes in that particular config.tx file, and we will look into it right now. Let us go to the code. So as you can see, this is the config.tx.yaml file, which we can see here. So we have different section over here, which you can see. So in this, you have organization section. As you can see here, for each organization which is part of the network, you are defining different policies. As you can see, you have orderer and you have organization 1, you have organization 2, you have organization 3. For each of the organization, you are defining different policies. Here we are choosing signature policy. As we have learned in the previous section, we have different types of policy. One is the signature policy and implicit meta policy. In here we are choosing signature policy, and the same goes for the other 3 organization as well. As you can see here, you have different types of policies that you have to define for that particular organization, and same goes to organization 2 and organization 3 as well. So this section includes the policies for organization. So you also have policies for applications as well. As you can see here, you have defined policies for application, and in this we are going for implicit meta policy. So that is it about how you are configuring the policies. Now moving on to where we have left from. So this is how we are going to configure in the config.tx.yaml for both organization and application. Moving on, so that is one way of configuring endorsement policy, which we have seen in config.tx.yaml file. There is another way of specifying an endorsement policy for and that is using the Fabric SDK. So you can also create an endorsement policy from your command line interface when you approve and commit a chain code definition with the Fabric PO binaries using -- signature -- policy flag. So we are going to see the command in detail. Now, as we already know, we have to go through different stages when we have to install and instantiate the chain code. As part of this, when we are trying to approve for a particular organization, which is this command that we are executing. So at this point of time also, we can set the endorsement policy, which you can see here, signature dash policy, and we are setting the endorsement policy over here. So this command means uh, it approves the chain code definition of my CC with the policy and which is which is defined here, and which could require that both members of organization 1 and organization 2 should sign the transaction. With why it is needed, both of these members are needed, it's because we are mentioning the expression as and. To make this command clear, I am gonna go and show it in VS Code so that you will get a clear picture of how this command looks like. So this first one is the command that we are talking here. So peer lifecycle chain code approve for my organization. Sorry, approve for my org. So here you are specifying the channel ID. Here in the third option, which is signature policy, you are specifying that both organization 1 and organization 2 member have to sign this transaction. So this is how it looks like, and here you are specifying the name, version, package ID. You are also specifying sequence. You are mentioning to use the TLS, and this is the CA file, which is the PEM file, and this is how the command looks like. And this is where this flag is where you are going to set the endorsement policy. Moving on to the next slide. So this is one more command, which is the command to commit the chain code. So in this command, which you can see, this means what this command is doing is, after a sufficient number of channel members approve a chain code definition for my CC, the definition and endorsement policy can be committed to the channel using this command. Now, let us go to VS Code again and see how this command looks like. So, this is the command, which is peer lifecycle chain code commit command. As you can see over here, you have signature policy and organization 1 member and organization 2 member. So rest of the commands, or sorry, rest of the option remains the same as with the first command which we have explained. The difference is here you are mentioning the peer address and also the certificates for both the members, which has to sign in this, as we already mentioned in the signature policy. As you can see, the member of organization 1 and member of organization 2 has to sign the transaction. So as part of member of organization 1, we have peer0 or .org1.example.com, which is running at port 7051. And you, for as part of organization 2 member, we have peer0.org2.example.com, which is running on 9051 port. So both of this has to sign this transaction. So this is how endorsement policy can be included in peer lifecycle chain code commit. Now let us go back to the presentation. Now we know that there is something called private data. So in order to refresh your memory, I'm just going to give a brief about what private data is. So private data brings the concept of data privacy among multiple participants without creating a separate channel for each other. If you want to go with Hyperledger Fabric documentation, it says in cases where a group of organization on a channel needs to keep data private from other organization on that channel, they have the option to create a new channel comprising just the organization who needs to access the data. However, creating separate channel in each of these cases creates additional administrative overhead, which are nothing but maintaining chain code versions, policies, MSPs, etc. And that doesn't allow for use cases in which you want all channel participants to see a transaction while keeping a portion of the data private. So this is where data private collection or private data collection comes into picture. So how we gonna specify the policies for this private data? Let us look into that. So for private data collection, you can also specify an endorsement policy at the private data collection level, which would override the chain code level endorsement policy for any keys in the private data collection, thereby further restricting which organization can write to a private data collection. Similar to chain code level endorsement policies, which we have seen in the previous section or previous slide, when you approve and commit a chain code definition, you can also specify the chain code's private data collection and corresponding collection level endorsement policies. If a collection level endorsement policy is set, the transactions that write to a private data collection key will require that the specified organization peers have endorsed the transaction. Now, you can see how the data that is present as part of the collection, which is a private data. So we can also um, write or we can also configure the endorsement policies for collection level data. So you can use this collection level endorsement policy to restrict which organization peers can write to private data collection key namespace. For example, in order to ensure that non-authorized organization cannot write to a collection, and you have a confidence that any state in a private data collection has to be endorsed by the required collection organization. So if you're not understanding what this private data collection is, I recommend you to go through a use case or a fabric documentation which is already available. I'm going to tell you the link as well. So before that, the one more point to mention is the syntax for collection level endorsement policies exactly matches with the syntax for chain code level endorsement policy. But the difference is in the collection configuration, you can specify an endorsement policy with either a signature policy or channel config policy. I'll explain you in detail and I'll also give you the documentation where this is explained with an example in Hyperledger Fabric documentation. So this is how it looks like. So it defines the collection policy for private data. So now let me go to that link which has this. So this is the link which says this gives the sample connection definition JSON file. This contains array which contains the collection definition. As you can see, you have only this that we have mentioned, which is this part. So this is the use case for a marble use case, which is there in the Hyperledger Fabric documentation. If you follow that use case, you can see here the collection marble private detail definition restrict access to subset of organization in the channel, which is it is restricting only to organization 1, which you can see here, right? So additionally, writing to this collection requires endorsement from an organization 1 peer, even though chain code level endorsement may require endorsement from organization 1 and organization 2. As we have seen during the chain code installation and instantiation, so we have given endorsement policy as either organization 1 or organization 2 has to approve that transaction. But when it comes to this private collection, here we are specifying only organization 1 has to approve for this private collection data. So here, so the reason why the reason is, since you have only organization 1 to approve to, so that is why the member only right is set to true, which means only client from organization 1 may invoke the chain code that writes to private collection. Please go through this use case so that you will understand what this private data collection is. And you can also write your own custom collections and your own custom policies as well. Moving on to the PPT. Now, how you are going to modify or upgrade the chain code? So it is as simple as that, as simple as the installation and the instantiation or the chain code starting that we have done during the previous slides that I have explained. So it is the same process that you have to follow in order to upgrade or modify the chain code. So that is it for this session, and in the follow-up session we are going to go
Thanks for watching. Please like and share this video.
into much more detail about the Hyperledger Fabric network configuration. That is it for this lecture, and we also have a private tutoring session for many courses including this courses as well. Please subscribe to private coaching session to get in deep one-to-one coaching sessions. Thank you for watching. I'll see you in the next section. Welcome back everyone. In this section, we are going to see how we are going to install and configure Hyperledger Fabric network. In the previous section, we have seen how are we going to install the peer chain code and how are we going to instantiate the chain code and how are we configuring the endorsement policies and how will we configure the endorsement policies for the private data which is present in Hyperledger Fabric network. In this section, we are going to look into these concepts, which are modifying the world state database configuration, defining initial multi-organization configuration policy, how are we going to configure ordering service, configuring Hyperledger Fabric container, defining the network configuration option, how are we going to enable the TLS for the communication, how we are going to generate the Genesis block and the commands that is used, and how to configure the service discovery node. Let's get on to the first topic, which is how we are going to modify the world state database configuration. Before moving on to that, to refresh your memory, a ledger consists of two states which are related to each other. One is blockchain and the second is the state database. State database is also called as world state data. So I have already explained that in previous sessions as well. So if you have not understand those concepts, please go back and revisit those lectures. And we know that the blockchains are immutable, and that is the reason once a block has been added to the chain, it cannot be changed. In contrast to that, world state is a database containing the current value of the set of key value pairs that have been added, modified, or deleted by the set of validated and committed transactions in the blockchain. So in order to modify the world state database configuration, you have two database options. First is level DB and the second one is couch DB. In Hyperledger Fabric, level DB is the default database. So you can configure the state database whether you are going for level DB or couch DB, and this configuration can be done in two ways. The first configuration way is using core.yaml. Now let us look into how we are going to set these details of world state database in core.yaml. So CouchDB is enabled as state database by changing the state database configuration option from Go level DB to CouchDB. This means that the state database configuration by default will be pointing to Go level DB. So that DB has to be changed to CouchDB for rich queries. So additionally, CouchDB address needs to be configured to point to CouchDB to be used by the peer. The username and the password properties should be populated with the admin username and password if CouchDB is configured with a username and password. So these changes has to be done in core.yaml and it will be effective immediately after restarting the peer. The summary of this is whenever you change the database from Go level to CouchDB, like any other database, if you have worked with MySQL database, you need to give a username and password. So same way, if you are using CouchDB also, you need to give the username and password and these changes has to be present in core.yaml. And the other way of modifying the world state database without core.yaml is using the Docker environment variables. So Docker environment variables will override whatever the default values that you have given in core.yaml. So when you give the values like this, for example, core ledger state database and other states like other variables like this. So when you whatever the value that you are going to give for this particular variable will be overridden by it will override the values that are present in core.yaml. So CouchDB hosted in Docker container supplied with Hyperledger Fabric have the capability of setting the CouchDB username and password with the environment variables passed with the CouchDB user and CouchDB password environment variables using Docker Compose scripting. As we have seen in core.yaml, we are going to set a CouchDB username and password. In Docker environment variable, if you want to override those variables, then you are going to set those value using these variables. So these variables will override the values that are present in core.yaml. So if you have already updated the CouchDB, then how are you going to upgrade the CouchDB if you want a newer version or if you want a new instance? For that, what you have to do is, so you have to follow these four processes. So you have to first stop the CouchDB, then you have to take the backup of the CouchDB data directory, and you have to install the latest CouchDB binaries or update deployment script to use a new Docker image. Later that, you have to restart the CouchDB, and after this process, your peer will be using the latest CouchDB instance. Next topic is defining initial multi-organization configuration policy. So we have already covered in the previous session how are we going to configure all these in config.tx.yaml. If you want to refresh the memory, please go back to the previous session and have a look and come back to this session and follow along. Next is configuring ordering service. So configuring ordering service is done in a file called orderer.yaml file. So setting up the ordering file, it takes a step-by-step process. So the process of bootstrapping an ordering node consists of the following four steps. First is creating the organization to which your orderer node belongs to. Then you have to configure your node using obviously orderer.yaml file. Then you have to create Genesis block for the orderer system channel. Next, you have to bootstrap the orderer. So we will look into one by one of all these processes. So first step in setting up an ordering node is creating an organization definition. Like peers, all orderers must belong to an organization that must be created before the orderer itself is created. This organization has a definition encapsulated by MSP that is created by certification authority dedicated to creating the certificates and MSP for the organization. If you recall from the previous section, while the network formation, I have explained that the orderer node should be part of a particular organization, and that particular organization will be facilitated by a certification authority. That certification authority will be responsible for providing certificates for the orderer. So uh, that is where this CA and MSP comes into picture. If you want to refresh your memory, please go back and revisit those lectures and come back and continue. Next step is configuring the node. The configuration of the orderer is handled through a YAML file called orderer.yaml, which we have already seen. The Fabric CFG path, which is an environment variable, and it is used to point to an orderer.yaml file which you have configured, which will extract a series of files and certificates on your file system. So if you want to get more details of how this orderer.yaml file looks like before we get on to lab, you can check on this Fabric sample GitHub repo, which will take you to that particular GitHub repo where you can see the properties that are present in orderer.yaml. Next step is configuring the node. In orderer.yaml, you have certain properties which you will find in orderer.yaml file. We will visit certain important properties here. You have local MSP ID. This is the name of the MSP generated by your certification authority of your orderer organization. So this is where your orderer organization admins will be listed. And you have property local MSP dir, which is directory. So this is the place which is nothing but a file system place where your local MSP is located. Then you have other options as well. You have TLS. So if it is by default, it is disabled, which means the value will be false. So this is where you specify whether you want to enable TLS or not. So if you set this value to true, you will have to specify the location of relevant TLS certificate. So this is not, so note that in version 2.0, this is mandatory for raft nodes because in version 2.0, we will be using raft as a consensus mechanism. Then you have the property bootstrap file. This is the name of the Genesis block you will generate for the ordering service. Then you have bootstrap method. This is the method by which the bootstrap block is given. Next in the process, you have to generate the Genesis block of the orderer. So the first block of a newly created channel is known as Genesis block. Since this is the first block, it's called Genesis block. If this Genesis block is being created as part of the creation of new network, in other words, if the orderer being created will not be joined to the existing cluster or orderers, then this Genesis block will be the first block of the orderer system channel. We have learned about different types of channel in the previous lecture. So the Genesis block of the orderer system channel is special, which means it must be created and included in the configuration of the node before the node can be started. Now, how are you going to bootstrap this orderer node which is prepped using the previous step? So once you have built the image and created the MSP, configured your orderer.yaml file, and you have already created the Genesis block, you are ready to start your orderer using the command that looks similar to this. And I'll explain and I'll type this command when we go for a lab section. So for time being, you have to remember that this is the command that you have to execute in order to bootstrap the ordering node. For bootstrapping, so we are going to use something called Docker Compose. So this is not a session for learning Docker. If you want to learn Docker more in detail, please subscribe to other courses which are present in coding bootcamps. For time being, you have to remember that you are going to use Docker and Docker Compose file in order to bootstrap the ordering node. Next is configuring Hyperledger Fabric container. So this can be done using another configuration file, another YAML file, which is dockercompose.yaml file. So before you can create a peer, you need to customize the configuration file for the peer. In Fabric, this file is core.yaml file. So there are quite a number of parameters you need to set for your network to work properly. So you will have below options which you can use for you to tune your configuration for your network. So you have to edit the YAML files bundled with the library, and you have to use the environment variables to override when deploying. As I told before, you either have to use the YAML property files, or you can use the Docker property file to override whatever the properties that are present in the YAML file. Meanwhile, you can also specify flags on the CLI command as well.
Thanks for watching. Feel free to add your questions as comments down below.
So moving forward in defining the network config option. So option 1 has the advantage of persisting your changes whenever you bring down and bring back up the node. So the downside is that you will have to port the option you customized to the new YAML when upgrading to new binary version. So what does this mean? So you have this previous option, which is edit the YAML file bundled with the binaries. So if you go with this first option, this is the advantage, which means the advantage is you can persist your changes whenever you bring down or bring back the node. But if you use the other two options, which is environment variables and specifying the flag, that means it is not persistent. Every time a environment variable is used to override, so this environment variables will override the existing YAML file, and it is not persistent if your network goes down. And the same thing goes with CLI commands as well. So these are some of the properties that are present in core.yaml that are explained here. So peer.local MSP ID. This is the name of the local MSP of your peer organization. This MSP is where your peer organization admins will be listed, as well as the peer organization's root certification authority and TLS certification authorities certificates are present. You have peer.msp config path. This is the place where the local MSP of the peer is located. You have peer address, where it represents the endpoint to other peers in the same organization. This is important to establish the gossip communication within the organization. So gossip communication is necessary to identify the other peers that are present in the organization. Then you have peer.tls. When you set this to enable, or when you set this to true, then you have to specify the location of relevant TLS certificates. You have property like ledger. So in this, user have number of decisions to make about the ledger, including the state database, as we have discussed before, which has two options. One is level DB and couch DB. And this is where you can give this property, and you can tell that this is the DB that we are going to use for state database or world state database. You have another property, gossip. So gossip data dissemination protocol is very much necessary for communicating between the peers and communicating to other peers as well. You have chaincode.external builders. This field is important to set when using chaincode as an external service. So there are many other properties as well. As you go through these properties, you will understand, as you go through these YAML files, you will understand there are many properties which are necessary for your network to have additional functionalities or customized functionalities in your network. One more property that you can set is enabling TLS for communication. So to enable TLS on peer node, you have to enable peer.tls.enable to true. So when you say TLS is enabled, you are telling that I want to securely communicate within the peers. So for that, you need to specify proper TLS server certificates as well. Next is how you are going to generate the Genesis block. As we have seen from the previous lectures that we need tools to generate Genesis block, and that tool is config txgen tool. So for config txgen tool, we are going to provide certain inputs or certain params like this. You are going to provide profile, you are going to provide channel ID, and you are going to provide output block. So this config tool is the command that you are going to execute, and it will be fed to config txgen tool. This will generate the orderer Genesis block. Here is the property that you have to set for configuring service discovery node. So you are gonna specify the one peer which is going to act as a service discovery node. Here in this slide, we are setting that peer, that gossip peer for service discovery node as peer 1 of organization, which is running on port 8051. That is it for this lecture. Please go through this lecture and understand each concepts. This will ease you in uh, when we go for lab section. So if you have any doubts, please feel free to ask in the comment section, or please feel free to subscribe for the private tutoring session for one-to-one guidance. Thank you for watching. I'll see you in the next session. Welcome back, guys. In this section, we are going to learn how we are going to troubleshoot the network and how we are going to diagnose what is the problem that has occurred in the network. To recap what we have learned in the last session, we have learned how to modify the world state database configuration, how we are going to configure ordering service, how to configure Hyperledger Fabric containers, how to define network configuration option, how to enable TLS, and also how to generate Genesis block, etc. In this section, we are going to look into troubleshooting the network, where we are going to see how the orderer locks and peer locks exist, and also we are going to look into certification authority locks and chaincode locks as well. Coming to the first section, which is querying and analyzing the peer and orderer logs. So logging in the peer and orderer is provided by common or flogging package. So this package supports logging control based on its severity of the message, logging control based on the software logger generating the message, different pretty printing option based on the severity of the message. So all the logs are currently directed to STD error, which is standard error. That is why it is standard STD and ERR error. Global and logger level control of logging by severity is provided for both users and developers. And all these three options that I have explained in the last section or last slide is same. So as we told, there are different level and severities as we have seen in the last slide. So this is the logging specification that we can see. So the logging level of the peer and orderer commands are controlled by logging specification, which is set via an environment variable, that is fabric logging spec, which you can see from this slide, which I'm showing it right here. Fabric underscore logging underscore spec environment variable. So the full logging level specification looks something like this. So here logging severity levels are specified using the case sensitive string chosen from these. So this level, which you can see as a right hand side input, takes these value. It can be either fatal, panic, error, warning, info, or debug. So the logging format of the peer and orderer commands is controlled via fabric logging format, which is this environment variable, which is marked in the red. So this can be set to a format string. So to print the logs in a human readable console format, it can also be set to JSON output logs in the JSON format. So if you don't understand these environment setting and how you actually see when you are trying to debug the network, I'm going to show how it looks like, how the logs looks like in both orderer and peer in the lab section. Next is query and analyze certification authority logs. The Fabric Certification Authority provides three ways to configure settings of the Fabric CA server and Fabric CA client. So the precedence order is, first is it takes the first precedence goes to CLI flag, the next goes to environment variables, and the next goes to configuration file. Now let us look into what does that precedence mean. So if we have the following in the client configuration, as you can see here, you have a configuration file to enable TLS, but at this point of time, this is disabled. Now you have one field over here, which is cert file, and you are giving an input, which is cert.pem. So this is actually happening at a file level. Next, so the file level is the least preference level which we have seen. So if you want to override whatever is present in the file, then you will go for these environment variables which are shown here. So this is the command that you are going to execute, where you are going to override that particular environment variable, and the value that you are going to pass it as part of this command will override, and the value that is cert2.pm will be the value of the previous value, which is previous property, which is cert file, which we have shown here. So this file's property cert file will get overridden by the value that we have provided in this environment variable. So if you want to override both environment variables and configuration file, then we can use the command line flag. So if you use this command line flag, which you can see here, so this command line flag will override both environment variable and also the configuration file, which we have seen in the previous slide. Next is all the properties in the Fabric CA server and client configuration file that specify file names support both relative and absolute path. Relative and absolute path are very commonly used in every programming language. So relative paths are relative to the config directory in case of Hyperledger Fabric, where the configuration file is located. Next is chaincode logging. So who is responsible for seeing the chaincode logs, and why this chaincode logs are very much necessary? So if a developer is developing a chaincode on top of the network, then it is very much necessary to debug the logs that is generated by the chaincode. So user provided chaincode may technically also produce output on std out or std error, which is standard output or standard error. While naturally useful for dev mode, these channels are normally disabled on a production network to mitigate abuse from broken or malicious code. This means there is something called dev mode which comes into picture when chain code developer is developing a chain code. So when he is trying to test that chain code with the use of dev mode, you can easily test your chain code without bringing down your network again and again. So this is the use of dev mode, and this dev mode will help in order to develop the chain code faster. And this dev mode should never be checked in to your code repository or also to your production network. However, it is possible to enable this output even for peer managed container, which is net mode, on a peer-to-peer basis via this environment variable or property, which is core underscore VM underscore docker underscore attach std out, and you are going to set this property to true in the configuration. Next is, once it is enabled, each chain code will receive its own logging channel keyed by its own container ID. As we have seen that we are going to spin up the container using Docker for each of the peer. So that is what gives the container ID. If you want to learn more about Docker, please subscribe to other courses that are present in coding bootcamps. So any output written to either std out, which is standard output, or standard error will be integrated with the POS log on a per line basis. It is not recommended to enable for this production. So in the production, it is recommended to turn this on.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Off so that the other person or the third person will not get to know what is happening inside your system. The std out and std error not forwarded to peer container can be viewed from the chain code container using standard commands for your container platform. So these are the commands that can be used for you to see the logs that is generated by the chain code when we are trying to execute the chain code. So these commands I'm gonna explain it to you in detail when we are trying to bring up the network and instantiate and initiate the chain code. So that is it for this lecture. In the next lecture, we are going to look into how to configure the ACL, how to create end user identity, how to revoke an identity, and how to configure and start Hyperledger Fabric CA. That is it for this lecture. If you want to learn more about these topics, and if you want more attention and one-to-one guidance, please subscribe for our private tutoring for all these sessions. Thank you for watching. I'll see you in the next section. Welcome back, everyone. In this section, we are going to have a detailed discussion on membership service provider or MSP. In the previous section, we have learned how to modify the world state database configuration, how to modify and add orderer configuration and ordering service, how to configure Hyperledger Fabric containers, how to define network config option, how we are enabling TLS, and how we are generating Genesis flow. These are the things that we have learned in the last section. In this section, we are going to learn more about membership service provider, and in that we are going to address how to configure ACL, which is access control list, how to create end user identity, revoking an identity, and configure and start Hyperledger Fabric CA, which is certification authority. Let's move on to the first subtopic, which is access control list. So, Fabric uses ACL to manage access to resources by associating to a policy. A policy is nothing but a specific rule that evaluates to true or false. Fabric contains a number of default ACL. So this topic is already covered in Fabric policies in the previous section. If you want to refresh your memory, please go back to those slides and have a look and read those lectures and come back and continue watching. Access control defaults exist inside config.tx.yaml file. This file is fed to config.tx gen which uses this file and builds the channel configuration. So, access control can be uploaded or updated in two ways. First is editing config.tx.yaml, which will be used when creating a new channel configuration. The second is updating access control in a channel configuration of an existing channel. Let us go and see both of this. So first one is editing config.tx.yaml. So ACLs are formatted as key value pair consist of a resource function name followed by a string. As you can see in this example, which is ACL policy for invoking chain codes on peer and ACL policy for sending block events. As you can see on the first example, the access to the left hand side, which is peer/propose, is restricted to identities satisfying the policies defined at the canonical path, which is the right hand side, which is /channel/application/writer. And it is the same for the second example as well. The access to event/block is restricted to identities satisfying the policies defined at the canonical path channel/application/reader. This is the explanation that I have just given for the previous slide. If you want, you can read it again to grasp more. Next is updating ACL defaults in config.tx.yaml. In cases where it is necessary to override ACL defaults when bootstrapping a network or to change ACL before a channel has been bootstrapped. So the best practice is to update in your config.txgen itself. Next is create end user identity. So here you will find different steps. So first is enrolling the bootstrap identity. So if needed, you can customize the CSR, which is certificate signing request section in the client configuration file. So you have different properties, and one of the properties, which is clr.cn field, it must be set to the ID of the bootstrap identity. So the default certificate signing request values are shown in the next slide. So which is this one. So if you can see, this is the code snippet for enrolling the bootstrap identity. In this you have different fields, and couple of them have some default values. For example, CN is the common name and O is the organization name, which we have given the value as Hyperledger Fabric. You have OU, which is organization unit. We have given Fabric CA as the value. Then we have L, which is the location or city. Then we have ST, which is the state. We have given it as North Carolina. And you have C as well, so which is name of the country. So right now in this code snippet we have mentioned it as US. So this is the code snippet where we will be handling the properties in order to enroll the bootstrap identity. This is just the example or the attributes which I have explained in the previous code snippet. Moving on. Next is enrolling the bootstrap identity. So Fabric CA client is responsible for enrolling an identity. So Fabric CA client, which you can see here, is the command that is used to enroll an identity. For example, if you see in this code snippet, so you can see Fabric CA client command is enrolling an identity, and that identity is nothing but it is having an admin privilege. I mean admin as the username and admin PW as the password. And this is calling Fabric CA server as a endpoint. if you can see where you are calling the http/admin pw, which is the password @ localhost 7054. Localhost 7054 is where your Fabric CA server is running. So the enroll command stores an enrollment certificate, which is ECERT, corresponding to private key and certification authority certificate chain PEMP files in the subdirectory of Fabric CA's client's MSP directory. Next is registering a new identity. The identity performing the register request must be currently enrolled and must have the proper authority to register the type of an identity that is being registered. As part of this process, it goes through 3 authorization checks that are made by Fabric CA server during the registration process of a new identity. That process involves: first is the registrar or the invoker must have the property hf.register.roles attribute with a comma separated list of values where one of the values is equal to the type of identity that is being registered. Next check is the affiliation of register must be equal to or prefix of the affiliation of identity that is being registered previously. Next, as part of the third process, the registrar can register an identity with the attributes if all of the following conditions are satisfied, which is register can register Fabric CA reserved attributes that have the prefix hf dot, and only if the registrar processes the attributes and it is part of the value of this property, which is hf.register.attributes property. Then registering custom attributes. This requires that the register has hf.register.attributes with the value of the attribute or the pattern that is being registered as well. One important thing to notice here is you can give the pattern also as a value to an attribute, which is hf.register.attributes. So if the registered attribute name is hf.register.attributes, an additional check is performed to see if the requested values for this attribute are equal to or a subset of register's value for hf.register.attributes. So in order to learn more about these registering a new identity, you can go through the course material that is attached with this course. There you will get much more examples to see the identification scenario for registering a new identity. Next is revoking an identity. As we have seen in the previous sessions that we can also revoke an identity if in case the certificate is old or certification needs to be revoked or something of that scenario. So an identity or the certificate can be revoked. Revoking an identity will revoke all the certificates owned by the identity and will also prevent that the identity from it prevents the identity from getting any new certificates. So revoking a certificate will invalidate a single certificate. So in order to revoke a certificate or an identity, the calling identity must have the property which is hf.revoker and hf.register.roles attribute. The revoking identity can only revoke a certificate or an identity that has an affiliation that is equal to or prefixed by revoking identity's affiliation. Furthermore, the revoker can only revoke identities with the types that are listed in the property, which is hf.register.roles, which belongs to revokers. For example, as you can go through this, as you can see this example, the revoker with affiliation args.arg1 and the property hf.register.roles is equal to peer or client attributes can revoke either peer or client type of identity affiliated with args.arg1 or args.arg1.department, but it cannot revoke an identity affiliated to args.arg2 or of any other type, meaning it can only revoke only the type peer or client, not admin and the other types. And also it's the same, so if it is affiliated with this organization which is arcs.org, it can affiliate, it can revoke only for that particular organization and the subsets the and the and the certificates that are associated with that particular organization, not the certificates of other organization. So the following command disables an identity and revokes all of the certificates associated with the identity. So all future requests received by the Fabric CA server from this identity will be rejected. So this is the command that we will use in order to revoke the certificates, in order to disable an identity and also revoke the certificate. So this is kind of like a deeper understanding of how revoking an identity works. So an IDE mix CRI, which is credential revocation information, is similar in the purpose to an X509 CRL to invoke what is previously issued. However, there are some differences between X509 CRL and also IDE mix CRI. So in X509, the issuer revokes an end user certificate and its ID is included in the CRL. The verifier checks to see if the user certificate is in the CRL, and if so, it returns an authorization failure. The end user is not involved in this revocation process other than receiving an authorization error from the verifier. So this is some more extra information about IDE mix. So in IDE mix, the end user is involved.
Thanks for watching. Please like and share this video.
The issuer revokes an end user's credential similar to X509, and evidence of this revocation is recorded in the CRI. The CRI is given to the end user, which is also called as prover. So the end user then generates a proof that their credential has not been revoked according to the CRA. So the end user gives this proof to the verifier who wants to verify the proof according to the CRA. For verification to be succeeded, the version of the CRI used by the end user and the verifier must be the same. So if it is same, that means you can go ahead and the revocation is been successful and the verification matches. If you want to get more information about how to revoke an identity and other registering the identities in Hyperledger Fabric, please go through the course materials which we have attached along with this PPT. Next is how we are going to configure and start Hyperledger Fabric CA, which is Certification Authority. So we have a diagram coming up which will explain you how the Fabric CA server and Fabric client interacts with each other. So there are two ways of interacting with Hyperledger Fabric CA. That is, one first way is via Hyperledger Fabric CA client, or it's through Fabric SDKs. So all communications in Hyperledger Fabric CA is via REST API calls. Let me explain you this diagram. So this diagram, you can see two major components. One is Fabric CA server and Fabric CA client. As you can see, Fabric CA root server will be associated with the Fabric CA intermediate server. And the intermediate server can have multiple server for high availability. So if you see, this is a single server, but internally it might be a cluster of other servers, other Fabric CA server, and it is maintained by this intermediary server. Or you can also have the same cluster of this CA server as well. This improves the high availability for your Fabric architecture or Fabric network. So Fabric CA client connects to the intermediate server, which is the Fabric CA server, or it can also directly connect to the cluster of Fabric CA server. Then you have SDKs in order to communicate between the Fabric CA server and also peers. So this is an explanation where you can see the interaction between the Fabric CA client and Fabric CA server, and how your peers uses SDK in order to talk to Fabric CA server. So this is just the explanation what I have given before. So these are much more detailed information of how and why this high availability proxy endpoint is needed and things like that. So just to glance through these points, the Hyperledger Fabric CA client or SDK may connect to the server in a cluster of Hyperledger Fabric CA server. This is illustrated in the top right section of the diagram in the previous slide, which is the right section which I have told here. Next is the client routes to an high availability proxy endpoint which load balances the traffic to one of the Fabric CA server cluster member. So when it comes to high availability, the more number of servers means the high availability is achieved. So if you have more number of servers which can serve the users, which means none of the users request will go unnoticed by the server. So all Hyperledger Fabric CA servers in a cluster share the same database for keeping track of identities and certificates. In LDAP, if LDAP is configured, the identity information is kept in LDAP rather than the database. So LDAP is again a detailed configuration. So if you want to learn more about LDAP, please take other courses as well or Google it as well. So a server may contains multiple certification authorities. Each certification authority is either a root certification authority or an intermediate certification authority. So each intermediate certification authority has a parent CA, which is either a root CA or another intermediate CA. This is nothing but the root CA and intermediate CA, and this can be connected to this is the intermediate server is connected to a root server. Moving on, how are you going to configure and start the Hyperledger Fabric CA? So in order to initialize the Fabric CA server, you need to run this command, which is Fabric CA server init -b and the credentials over here, which is admin password. So the server configuration file contains the certificate signing request, which is CSR section that can be configured. We have already seen a code snippet where CSR is enrolled with the Bootstrap identity section. Then how are you going to start the server? So Fabric CA server start is the command which is used to start your Fabric CA server. So if the server has not been previously initialized, it will initialize itself as a start for the first time. So during this initialization, the server will generate a CA cert PEM file and CA key PEM files. So if they don't exist, it will also create a default configuration file if it doesn't exist. So this is the command which is majorly used to start the Fabric CA client. If you're not understanding how this command is executed, when we go to the lab section, I am going to execute this command and I'm going to show it to you how it is starting the server in the logs. So you can also upgrade the Fabric CA server. So the Fabric CA server must be upgraded before upgrading the Fabric CA client. So prior to upgrade, it is suggested that the current database should be backed up. So if you are using Squite 3, back up the current database, which is named under Fabric CA fabric-ca-server.db by default. So for other database type, use the appropriate backup or replication mechanism. So to upgrade single instance of Fabric CA server, you have to follow certain process. First is you have to stop the Fabric CA server process, and you have to ensure that the backup has been taken for the current database, and you have to replace previous Fabric CA server binary with the upgraded version. Then you have to launch the Fabric CA server process, and you have to verify the Fabric CA server process is available with the command where you can reach that particular server, and that command is fabric ca client and get ca info. User it will be whole http and where your server is running. So in this example, if you take your host as a local host, then in the local host at port 47054 is where your fabric server is running. So if you want to get more information about this process, you have to go through the course material attached along with this PPTs. So that is it for this lecture. I know this is an elaborated view, but the certification authority in Hyperledger Fabric might be confusing. So please go through all the course material to get understanding of what we have talked before. And if you have any questions or any follow-up that has to be done, please feel free to ask. And also we do provide private tutoring sessions as well. So please do subscribe for the private tutoring session from Coding Bootcamps. Thank you for watching. I'll see you in the next section. Welcome back, everyone. In this section, we are going to look into network maintenance and operations. So in the previous section, we have seen how to modify the world state database configuration, how do you configure ordering service, how do you configure Hyperledger Fabric containers, how to define network config option, how we can enable transport layer security, which is TLS, and how can we generate Genesis block. And in this section, we are going to look into network maintenance and operations. So as part of this, we are going to look into how we are going to add a peer to an existing organization, and how we are going to create a channel and add an organization to the channel and update the configuration of a channel. First subsection is adding peer to the existing organization. So we can achieve this using the following 5 steps. If you don't understand these 5 steps, please don't worry, because we will be following these steps in project 2 as well. So if you please follow through all these theory steps and understand the theory behind it. As we go through the lab and execute the commands, it will become more clear and you will be able to grasp every single concept in this theory section. So first one is, whenever you are trying to add a new organization, you have to generate the crypto material using Cryptogen tool. So Cryptogen tool, as we have already seen in the previous sections and the previous lectures as well, it is used to create the crypto material for a particular organization. So we will be using the same Cryptogen tool, and we will be feeding our configuration file to the Cryptogen tool to generate the crypto material for the new organization that we will be adding. Next, we will be spawning the new peer and CouchDB container using the Docker. So for every peer or every organization which is or adding the peers, for each peer we need to configure CouchDB and CouchDB database for that container. So that we will be doing it with the help of Docker. Next, we will be joining the peer to existing channel on the network. So once we spin up the network, for example, in the previous section, we have discussed that when we spin up the network, you have the containers already running for particular organization peers. For example, if you have two organization, you have each of them providing you or facilitating one peer each, which means you have two containers running. So these two containers or these two peers have already joined the channel. So now that we are adding one more peer to the channel, so we need to make sure that that peer is added to the existing channel where the previous peers are also part of. Next, we need to set up some environment variable to execute them on CLI terminal. So we will see how we are going to set the environment variable to act as a different admin of different organization when we get inside a CLI using Docker command. After that, um, after that we will join the peer to the channel. So this is a process where we have to run a lot of Docker commands, and we need to get inside a Docker command to change your environment to act as some other organization. And then you have to create a channel artifacts, and you have to run other commands as well. So this is again a process that we have to follow, and this process is well explained in the project 2 that we will be covering soon. Um, so that is it for this lecture. In the next lecture, we're going to see how we're going to create a channel when we are trying to add a new organization to the existing channel. See you in the next section. Moving on to creating a channel. So, when the orderer receives a config update for a channel which does not exist, the orderer assumes that this must be a channel creation request and performs a set of activities. And these activities are listed here. So, the orderer first identifies the consortium which the channel creation request is to be performed for. So it does this by looking at the consortium value of the top level group. Next, the orderer verifies that the organization included in the application group or a subset of organization included in the corresponding consortium and the application group is set to version 1. Next, the orderer verifies if the consortium has members.
Thanks for watching. Feel free to add your questions as comments down below.
That the new channel has also has an application member. That means creation of consortium and channel with no members is useful only for testing purpose. So the orderer creates a template configuration by taking orderer group from ordering system channel and and creating an application group with the newly specified members and specifying its mod underscore policy to be the channel creation policy as specified in the consortium config. So if you don't understand the model policy and the consortium config, so once you get into the lab section, so you can see the files that it will be creating and it will be clear to you. So please follow along. So the orderer then applies the config update as an update to the template configuration because the config update applies modification to the application group, which is currently version 1. So the config code validates these update against the channel creation policy. If the channel creation contains any other modification such as an individual organization's anchor peers and the corresponding mod policy for the element will be invoked. Next step is the new config transaction with the new channel config is wrapped and sent for an ordering in order for the ordering system channel. After ordering, the channel is created. So the process of creation of this channel is much more complicated. So if you want to learn more or if you want to get deep dive into this channel creation process, wait until we get into the lab section. But if you want to get more theoretical knowledge, please go through the course material that we have provided along with this lecture. So that is it for this lecture. In the next lecture, we are going to look into the process of adding an organization to the channel. I'll see you in the next section. Thank you for watching. Moving on to adding an organization to the channel. So the first step is to check that you have a clean version of a network running on your machine. Then we can start the process of adding a new organization 3 to the channel that we have created. In the next step, we are going to use a script to add organization 3 to the channel. And this script is this script has all the procedures that are required to add the organization 3 and bring it to the channel. Next, we will go through a step-by-step process of adding organization 3 and updating channel configuration. So in the step-by-step process, we will go through certain steps, and all these steps are mentioned in the lab section. So whatever the steps that we are mentioning here or the script running, it is actually implemented and it is actually executed in the project 2 section. So if you don't understand the theory part when I'm trying to explain, don't worry, you will get it when you go through and follow through project 2 lab section, which will be coming up. So once we are ready to add organization 3 to the channel, as a first step, we need to generate organization 3 scripto material. That means we are going to create the certificates and keys for the organization 3 peer along with the application and admin user. Because we are updating our channel, we should use CryptoGen tool instead of using certification authority. So once we have created organization 3 crypto material, we can use TXGen tool to print out organization 3's organization definition. So after that, after we have created organization 3 crypto material, we can bring up the network, which bring up organization 3 peer. So there is a folder in your test network, which is add org3 directory. And from that directory, you are going to issue the docker compose command for you to bring up organization 3. So once you execute this command, you will have two containers ready. One is for organization 3's peer and another one is the peer CLI, organization 3's peer CLI. So don't worry about the commands at this point of time. So you can execute and follow through the commands in project 2 section. So for time being, you have to understand the theory part of it. And as I've explained before as well, this is not the course where I'll be explaining in details about detailing about Docker. If you want to learn more about Docker, please do subscribe for other courses that are present in coding bootcamps. Moving on, after that, as I explained, once you execute this command successfully, you will have two containers. One is the peer container, which you can see here, and then you have another CLI container. Next, you have to prepare the CLI environment. As we have discussed in the previous sections, that you have to set certain environment variables so that you can act on behalf of an admin of a particular organization. So that is what we will be doing, and we will prepare the CLI environment. So the update process makes use of the configuration translator tool, which is config txlater, which is translator. This tool provides a stateless REST API independent of the SDK. Additionally, it provides a CLI tool that can be used to simplify configuration tasks in the Fabric network. Next, you need to fetch the configuration. After we have organization 3li container with our two key environment variables, which we are going to set inside organization 3 CLI, and it is exported from the previous step. Then after that, we will move on to fetching the most recent config block for the channel, which is my channel. Then we will convert the configuration to JSON and trim it down. So we will use config txlater or translator tool to decode this channel configuration block into JSON format. We must also strip away all the headers, metadata, creator signature, and so on, so that are not relevant or that are relevant to change what we want. So we can accomplish by using this tool, which is JQ tool. So if you don't understand all this, the same concepts and the same explanation I'll be explaining again in the project 2 section, in the lab section. So please be with me. Next is adding an organization 3 crypto material. So we will use this JQ tool once more to append the organization 3 configuration definition, which is arg3.json. I'm going to show in the lab section, which is the command that you have to execute in order to get arg3.json. So this arc3.json is used. So we will append this to the channel application group field, and the name of the output, meaning the file which is generated after this, is modified config.json. So we are going to see all these file modification in action in the lab section. Next is you have to sign and submit the config update. So now that we have protobuf binary, and you have other files that have generated as part of executing the commands within the CLI container. Uh, After that also, we need signature from admin users before the config is written to the ledger. So after you get the signature, then you can join organization tree to the channel. So at this point of time, the channel's configuration has been updated if you have executed all the commands properly from the previous section. And you are ready to include the new organization 3 to the channel. So after this, the channel configuration or config TX has already been covered in the previous section. So if you want to know more about the channel update configuration and also the channel management, please read through the course materials that is available in this Hyperledger course. So that is it for this lecture. If you don't understand the theory that I've explained in this set of in this set of lectures, please don't worry. The same thing I'll be explaining in project 2 of the lab section. So following is you have other section coming up which includes introduction to Hyperledger Explorer, and you in that we will look into the block details, peer list, and we will look into chain code list, the transaction details, and how are we gonna install Hyperledger Explorer. We do have one more lab where I'll be explaining how to install and how to look into all those details in Hyperledger Explorer. So that is it for this lecture, and we do have private tutoring as well. So please do subscribe for private tutoring to get one-to-one interaction and one-to-one guidance. Thank you for watching. I'll see you in the next section. Welcome back, everyone. I would like to thank you for taking this course by Coding Bootcamps. This course was all about Hyperledger Fabric for system admins. In this course, we have seen what blockchain technology is, anatomy of blockchain, Hyperledger blockchain ecosystem, components and architecture of Hyperledger Fabric, application lifecycle management, installing and configuring Hyperledger Fabric network, and we have also done some troubleshooting on the network. We have seen how membership service provider works in Hyperledger Fabric network, and we have also seen the network maintenance and operations. As part of this course, you have successfully finished 2 lab sections. In the first lab or in the first project, we have created and interacted with the Hyperledger Fabric network. So we have created the Hyperledger Fabric network from ground up, and we have interacted with the same. As part of the lab 2, which is project 2, we added an organization to the existing fabric network that we have created in lab 1, and we have added that organization to the fabric channel. By this time, you should have a strong understanding of how to bring up the Hyperledger Fabric network on your own. So I would like to congratulate you on taking this course and successfully finishing this course. If you like to know more about Hyperledger Fabric and the smart contract development, please do check out my course Hyperledger Fabric for Developers, which is listed here. We do have other courses as well. Please do go through the links. If it interests you, please do subscribe for those courses. I would like to again thank you for taking this course by Coding Bootcamps. Please do follow us on the social media links which are given here. All the best. Thank you.